Hi, good morning.
Morning. Yeah, I think today we will check.
Morning.
Later around 9:40 like that, we will be Singapore. Friday I sent you some personal sponsor request. And the email. Friday the WhatsApp. Friday or Saturday? Saturday, I think Saturday.
Yesterday. Friday got
Adan video. So Gabriel is one of the students, right? Okay. Yeah, this one of the results. So I sent on not Friday, actually Thursday itself I sent. Got two different email, but I think it's the same person.
Okay,
Yeah, this one. Omron. Okay. This one. This one, then another I share that for us. Two more personal use. One is a foreign one.
How are you today?
You had your breakfast ready?
Oh yeah. I tried different places today.
Good.
Near Sutera Mall. You know,
Near
Sutera-
Sutera Mall.
Yeah, so there's this like L-shaped place, right, where all the shops are. Yeah.
If you want lunchtime, you can go there. This building over here, Greenfield.
Yeah.
Okay. All the way straight. Then just look up on your left. There's one Chinese restaurant over there. Chicken rice, got everything.
What's the name of the place, do you know?
You remember? I also don't know.
I already placed a Grab order for delivery.
Oh, yeah.
12:30, I expect already. I pre-order already.
That one used to be this one like kopitiam lah.
Yeah.
So if you go straight, the shop will be right in front of you. The food will be reasonable.
Check back. Yesterday we also had a dinner at the Sutera Mall.
Oh, okay. Drama there got so many choices.
There's this Taiwanese food there. You should.
Mostly Taiwan, Korean foods are plenty.
Yeah, I should. I think got all the wedding people there yesterday.
Okay. Alright, carry on.
Alright. Thank you, sir.
one project first.
Okay, sounds good. I love it.
Okay. So I show you if we have a project, so how to create the flowchart first, then create the IO, then only we do program lah. Okay.
Think through the logic first.
Yeah.
Okay.
So because then I think after that we don't have time for projects. We move on to the other parts. Okay. Because whatever we already done, so we can use for the project. So yesterday we see the functions, right? Some functions like timers, some timers, the pulse also, the normal pulse and the pulse trigger. Okay. So it's depend on the situation, Okay, depend on, like yesterday we used the pulse like this, right? Only one time, correct?
Yeah.
If we have 2 bits, we use the pulse trigger. Okay. So actually, if let's say if I have something like this, okay, but let's say you don't know how to use this pulse trigger, okay, you don't know this one exists, okay, still you can do program, okay, but you need to check how to do the program. These functions, right? These functions, these instructions, all we have so many instructions. All the instructions will help you to do a simple program, like the timer also. Yesterday, okay, we help you to create a simpler program. Yesterday, the TP, TONR, the TOF, all without using if you want to use TON all the way, also can. Okay. So for example, I just give you for the TOF. How the TOF work? How the TOF work? If there is an input, then TOF. If the input on, the output on. If the input off, after 10 seconds, then only the output off. Correct? That's how it goes. Okay. Let's say for example, I have heater. Example, a heating element, the heater and exhaust fan. Example, okay. So means when the heater on, this one is the exhaust fan is on. When the heater off, the exhaust fan is still on for 10 seconds, then only the exhaust fan off. So this is the program. Okay. So when we, of course above this got some programming right, to on the heater. But my idea is when the heater on, the fan on. When the heater off, after 10 seconds, then only the fan off. So that is the process. Okay. So if you know how to use the TOF, just simplify like this only. Let's say you don't know how to use the TOF, you still can use the TON, but the program will be a bit bigger.
Yeah.
Okay? How? Okay. Let's say when the heater on, you want to on the exhaust fan first. Okay. Then exhaust fan. Because when the heater off, exhaust fan still need to be on. So that's why I do the latching. Okay. But now when the heater off, after 10 seconds only, the fan must be off. So what I do, I put the exhaust fan timer. But heater on, exhaust fan on. Here exhaust fan on, the timer will start. Right?
Yeah.
So what I do here, I put an interlock. That is, if the heater is still on, so I cannot run the timer. So after the timer, I off. See, now when the heater on, here also on, so it will cut off here.
Yeah.
So the fan will on, so the fan will on, will ready. Okay. Then the moment heater off, this one will go back to normally close. So timer will start. After the timer, this memory on, this memory will cut off.
Okay.
Okay.
Yeah.
So actually, you see, both are the same program.
Actually, I noticed that your flow, right?
Yeah.
Every time you will follow the main logic first, Then after that, what you want to do, then you add in the
Yeah,
after.
that is how you do the logic.
Yeah.
You see, actually I know I want to add here,
Yeah.
but I didn't add first.
Yeah.
Right. So
Yeah,
I
good
do this,
idea.
I do the latching, I do this. Initially I didn't add
Yeah,
this.
yeah.
I put this one, then I know, okay, when the timer need to on, after the heater on, then we have to do.
Yeah.
So when I draw also, I draw the same way we
Yeah.
do the program, so it will be easier for you to
Yeah.
understand. Okay?
Good idea.
Yeah, that's how you need to do the program.
Yeah.
Later I do the project, you will understand.
Okay.
Okay, so you see, both are the same process. Okay, both are the same thing only. But one you using TOF, make your program simple. Another one, you don't know how to use TOF. So you only know how to use TOF. So you do program like this. Okay, so that's the function of all the instructions.
Yeah.
Actually, if you see, if you go back to some older PLCs like S5, don't have that much of instruction.
All is
Yeah.
basic blocks.
Basic box, okay. Timer of course, because TON and TOF is common. You know why? Because you see how the PLC developed. Okay, you see, before PLC they were using relays.
Relays, yeah.
Relays,
Yeah.
relays. So we have a push button, normally open. We have a normally close, push button, normally close. Then we have a relay. Relay have a coil. This is the coil. Then the same relay will have a coil and contact. That is the coil and contact of the relay. Okay. If I want to change this into without a PLC, the same thing. I put a push button. I put a relay and I use the relay to hold back. Okay. Then use the relay, and for timer, right? There's a timer relay.
Yeah, remember, yeah.
Yeah, there's a timer relay.
Yeah.
Timer relay also, they have a TON, TOF type also. Both also they have. And for the timer also, we have a in and one coil. So the same thing in the ladder logic also, in PLC also.
Oh, okay.
All this is actually developed from the PLC,
Relay.
I mean the relay system,
Yeah.
hard wiring. Okay, and nowadays only so many of course lah, this pulse function all don't have lah. This pulse trigger all don't have because all these are inside the PLCs. Okay, and so many counter, comparator or other functions all is actually in the PLC systems. Okay, the basic one is this one all is actually our normally push buttons. Okay, relay, timer, set, reset also they have a relay called latch relay. Means some relay you give the input, power on, relay will trigger. You power off, relay will off. Okay. There's some relay will have two input. One is to on, one is to off.
Oh,
Same like set, reset. That one they call latch relay.
that one I never see before.
No, that one is not common in industry. Before PLC, yes, it's common. Now it's not common. Now it's normal relay.
Set, reset.
Why still? Okay, you can ask me. We already started using PLC. Why still we want to use a relay, right? Because very simple. Okay, you see, your PLC output is what? 24 volt.
Yeah.
Correct. Okay. Let's say you want to energize this lamp, for example. This is a 230. So directly I cannot on. So I use a relay to on.
Yeah.
So that is the function of relay.
Okay.
And also, because my output will energize the relay will on the lamp.
But there are PLCs with the relay function.
Yes,
Yeah.
there's a PLC. That PLC you can take. That the 1200.
Yeah.
That's 1200. No,
Yeah.
there's a small 1200.
Yeah.
2002.
1002 is yeah.
You know, you see, it's the data, right?
Oh yeah.
Correct.
But this one has 3 dots at the end. That means those are not used.
Which one? No, not used, not used.
3 dots.
Not used. Relay type. So for relay type, no need L plus M. Just one L enough. Means one L means it's a 230 volt.
Okay.
So relay means very simple. Whatever you connect at the L, that will be your output.
Oh, okay.
If you connect 230, your output is 230. If you connect 24, your output is 24. But why I still don't use this relay?
Yeah.
Because you see at the side here, can you see DQ?
Yeah.
What is that? 4 times relay.
4 times relay 30 volt DC, 250 VAC, 2 amps.
2 amps per point. Means the terminal can go up to 2 amps only.
Then after that kaput already.
Yes.
That's not very high.
Yes. So if let's say your device is higher, so that is the reason they use external relay.
Yeah.
And some, if you ask me, external, if your devices is running on 230 volt, higher watts, right? 2 amps, 3 amps. I mean less amps is okay.
Yeah.
Amps was still okay lah. But let's say motor, pump, higher amps.
Yeah.
If you ask me, better to use an external relay.
Yeah.
You know why? Because if anything happen, only burn that relay.
That's
The
right.
PLC won't. Because I've done one troubleshoot here. There's one company here. They, you know the water can, the big water can.
Yeah.
Okay. So this company is they fill the water lah. Okay. So there's a machine. So they will put like the bottle like this empty bottle.
Okay.
So it will spray water, clean up. Then next station spray air, clean up. Then it will go like this. Then once it go down like this, there will be another conveyor. This conveyor will move this way to fill first. Second one is to fill the cap. Third one is close, then go up. Okay. What happened? One time they called me. There's one function is not working. I think there's a function for spray the water. Okay, not working. So it's a Mitsubishi PLC. So when they call me, then I go and troubleshoot. Then I see one of the output is burned.
Oh.
Means you can see the lamp.
Okay.
But if you measure the signal here, there is no signal.
Shorted already.
Okay, it's a relay PLC.
Okay.
Means direct go to the contactor.
Oh.
From the contactor, direct go to the pump. Okay. Then what I do? Okay, I go and troubleshoot. Then I see there's one more spare. So in the program, I change that.
Change the value only.
Change the address.
Yeah.
So what happened? Let's say Q0.3. So it's already burned. Then I see in the program in the output which one is
The 4
available.
is not used. So
Let's
we
say
finish that one next
0.4, 0.5 lah. Okay. Then I inform them. I say because I think it's because it's a water right inside water. So maybe it's short. So that's why it give back. It's supposed to be from the PLC go out the voltage, but I think the voltage come back. So it become like short. Okay. So that's why it burn. And I say better to use external relay.
Yeah.
They didn't listen. Okay. Then they say never. Okay. And after 6 months.
Want to spend money,
Yeah. Then after 6 months they call me. Again a problem. Then I say of course I can change the PLC. So I charge I think not much, very less the price. I think I charge for the PLC and do back the wiring, take up. I think around 1,000. Only the workmanship 1,500. They say oh expensive cannot pay. Okay, never mind. Then they call, they buy the PLC from Mitsubishi. Mitsubishi come, they do for free, the wiring. Okay, same thing. After 6 months, same thing. The output burn again. Okay, they call me again. Then I say, okay, I got another one more spare. I put it back. Then ask me what is solution. I say this is the problem because the company don't have engineers. The technician, the small company lah. Technician, then the HR officials lah. Then I say. I told the HR, okay, this is the problem. You see, this is the output. Go to here. Okay, the load is higher. Okay, so that's why it burn. So proper solution is use external relay. Then say okay, no space also in the panel. Then I put all the output, one set of relay that I put. Then all the output initially is 230 volt.
Yeah.
I change back to 24 volt.
Okay.
So 24 volt. Then the 24 volt will activate the relay. Relay will activate the contactor.
Yeah, that's the correct way lah.
Correct way lah.
Yeah.
After that, no more call already. It's done. After I change, no more call.
Problem.
Problem solved.
Yeah.
Okay.
No, new problem.
Okay. So that's the thing lah. Okay. So in the PLC got so many functions. These functions will help you to simplify your program. Okay. So of course lah, we cannot. Even you ask me also, I also never use all the functions. Okay, the functions I write down here is the common I use. I see in programs when I troubleshoot. Then I see in company programs when participants bring the programs. I see them. Okay, it's the common one. Other than this, not all the machine using, some machines got used like, because there are so many functions here. Okay. So now we see how to create a program, a logic. Okay, from a flow chart. First, we need to create a flow chart. Let's say the program yesterday we do like the start stop, the 3 motor on, something like that. In the flow chart, you will have a 2 symbol. This is the flow chart I like to use. This one they call graph set. Okay, so this is the condition, and this is the function. Okay, so condition means what is the condition? Start button, sensor is detected, timer is done, all that. The function is what? Okay, motor on, motor off, pump on, pump off, like that. Okay. So let's say I do a simple one. When I press the start, motor 1 on. At the same time, I want to on a timer. Timer for 10 seconds. Okay. Then after the timer, means timer will give me an output, right? So when the timer reach, that is the timer cue. The timer is done. That is the condition. The function is motor 1 off, motor 2 on. Okay. Then motor 2 also I want a timer. Okay. Timer 2, let's say 10 seconds. Then after the motor 2 timer is done, motor 2 off. Okay, enough 2 motors enough. So when I press stop, motor 1 and motor 2 both off. Okay, so this is the program. Now we see how to create a program logic using this flowchart. When I start, this is the condition. Condition means always your condition like this, normally open or normally closed. This will be your output side. Okay. Motor need to be on. So how to on a motor? I can use a coil or set reset lah. So let's say I'm using a coil. Motor 1. That's all. Finish. Okay. So start motor 1. Okay. Then when the motor, because this is a push button item, right? So if let's say this is a sensor, I need to put it here on or off. But this is a push button, so I don't need this. Okay. So when I start motor on, after the timer only the motor will on. So until the timer running, motor need to be still on, right? So I latch it. Okay, because they won't tell you here. You need to do the holding. Okay. They just tell you start motor on. Okay. Then the same thing, start timer. Okay. So you want to use the TON. Okay. TON 10 seconds. But you know, for TON, I can use a push button here.
Yeah.
Because when I press, the timer will start. When I release, the timer will turn off. So what I can use here? So according to the flow here, the program here, when I start motor on, motor is always running, right?
Yeah.
So I can use the motor here. But according to the flow chart, the start must on the timer, right? Yes. But when I put the start on the timer, cannot. So I put the motor. Then after the timer will give me an output. Okay, so start motor on, timer done. Now I use the timer output to off the motor 1. Where is the motor 1 here? If I want to off this, need to cut off this, correct?
Yep.
But using a set, I need to reset it. Like this, just yesterday we do, right?
Yep.
Set, reset. So if I want to off, okay. So already off. Then the same timer on motor 2. So I go to 9. Okay. This one I need to latch or not? I don't know. Okay. This one I can imagine because this is a push button. But this one sometimes I cannot imagine. So what I do? No problem. You download this program and test. After you download, of course, because this memory will be the moment it on, it will off the motor. So when the motor off, timer will reset. This memory also will off. So this memory become on off. So to keep on the motor, I latch it. Okay. So motor on. Then the same timer on the motor 2. Okay. But we know this one is a on off. Right. So of course I can use this memory to run the timer. Okay, because for timer I need something to on. So according to this is the memory on the timer for 10 seconds. But I know this memory is not enough because this memory is on off. So same concept from here. So I use the motor 2. Then motor 2 will have output. So M0.0 already used, M0.1. Then this M0.1 will off the motor 2. Okay, where is motor 2? Here. Then when I stop, I off motor 1. Okay, where is motor 1? I want to off, how to off? I off this. So if I want to put it here or put it here also can, same thing. But easy to understand is here.
Yeah.
Okay? But if you put here also no problem, you can do. Then so motor 1 done, motor 2 is here. Stop. So that is how you create from the flowchart to a program logic. Okay?
Eventually we'll learn about the interrupts and stuff, right?
Of course.
Okay.
Because this program don't have any interlocks or that, right? Later when you do programs, interlocks or because it's not much, because just a push button, start, stop, it done, finish. Okay? But later when you add a sensors, everything, later after you write the program, then you need to test. Okay? Suddenly the sensor on, what happened? Okay? Suddenly when it's running, suddenly the sensor off, what happened? So all that later when you have sensors, then you will see lah. Okay? But this is the main flow you need to create first. From here later on when you test, then you have some problem. Then only you put some interlocks. Okay?
Okay, sounds good.
Alright.
Yeah.
Okay. So what we do? We do one project. Okay? So I do something like this. I create a project here. I create a flowchart. Then we try to do a project. Okay? Can I erase this?
Yeah, picture already.
Okay, picture.
Yeah. Because the time I tried to ask someone to do the programming for me. So he was asking me to do this graph set as well.
Okay.
But I didn't write it in the format that you just did.
Yeah.
So he couldn't understand what I want to do because I think my thinking is not the condition and function.
No, I know because
Yeah.
you know who will create this. Actually, when we are, because here means I take small projects means okay, because I'm the one who will design the wiring diagram, I'm the one who will design the so but still, like example for the UTM one, they give me, because that is the empty project, so I created from the scratch, the program, everything. So they give me a flowchart in their format, you know.
Same like me lah.
Of course, that's how you will create also. Even in the company also, big company also. Because okay, let's say like you want to buy a machine from me, of course. Okay, you won't give me a flowchart. You just tell me, okay, this is what I want the machine to do.
Yeah.
For example, to fill water here.
Yeah.
So you say, okay, I want a machine that is, I want to fill this water until this level, then I put it here, go wrap, then I put the water. So this is what you give me. Okay. Then of course your team, we will have our team and meeting. Okay. then from your team, you will have a process engineer, will give me a proper flow chart, but not in this format.
Okay.
Still will be a normal format. Okay. Sometimes it will be like this. Okay. When they press start, okay, they won't tell you also, press start. They say, okay, when I start the machine, okay, the conveyor need to run. Okay, when I put in the bottle, everything,
Yeah.
okay, then need to count everything. Okay. Then once I get this one, then in my team, there will be a process engineer who, from there, he will create a proper flow chart.
Okay.
Okay, but still not in this format also.
Still not in that format.
No,
Okay.
because he will give me, okay, when you press start, okay, the machine run, everything, okay. Then after that, when the flowchart comes to a PLC guy, he create this according to what is the IO. Because the process people, they just tell, okay, when I press start, the conveyor need to run, then I place the bottle, okay, need to count one by one. Okay. Because they don't know what is the IO, how many input, output you have. Okay, because when you put in here might have an input.
Yeah.
Okay, if the bottle is filling, the conveyor cannot run. So what you do a proper, you check the input output, you do a proper flow chart like this. This is where the PLC programmer will do.
Okay.
Okay, because why? Because they say, okay, this one fill up 10 minutes, 10 seconds, that's all. They just tell you 10 seconds. But when you do flow, you must put like this. Okay, when I start, the pump on, let's say when the sensor hit, the pump on, timer run, after the timer, the pump off. So this is where the programmer will create. Okay, so this one normally they won't create. When the process people, they won't create like this. Programmer only they will create, because programmer will create this based on your IO. Because the process people, they don't know how many sensors you have.
That one, the project kaput. The guy couldn't catch it. He totally didn't know what to do. So it was all scrap, the code all scrap. Yeah. Totally useless. It was a waste of time. Because in my head I already know what I want to do and how to check. Because they got the the vibratory dispenser, right? Then they will work in tandem with the load cell. So if there's nothing coming down for let's say 5 seconds, right, you just error and just cut, stop.
That's the thing, because
that's inside the microcontroller.
That's the thing, because there's a lot of freelance programmer.
Yeah.
For a programmer, you need to give all the details.
Yeah.
How many IO you need, how many IO you have. Okay. Then if let's say you want to give me a programming, you say okay, you do programming. Okay.
Yeah.
I will ask you, okay, what is the IO?
Yeah, he also asked me the same question.
What's the IO you have? Give me a flowchart.
Yeah.
But if I'm at the place means, okay, let's say you give me a flowchart, I know already. Okay, you don't know about this flowchart.
Yeah.
Okay, of course. So you give me how the machine works, the flow machine workflow. Okay. So what I do, I take the next step, because I involved in project.
Yeah.
Because I build wiring diagram all that. So I know how the program works. So I come there, maybe I come and look at the system, everything I do. Because
maybe I got the flowchart.
Oh, you have the flowchart? Because sometimes some of the programmers, they are really programmers only,
Yeah.
They are not machine makers. They are really programmer only. Programmer only is different actually.
Really?
Yes.
Wow, that's not very good.
Programmer only is different. Because even sometimes some of the machine makers, they don't have a programmer. They hire these freelance programmers. In the company, they have a guy to test the machine, test the program, all they have. But real programmers, they don't have.
You want to have a look something like this? Or you want to cycle back to this later?
No, I just want to see.
But
This is a normal.
Yeah, so it's in Chinese.
Yeah, but
So-
this is how it works now. Correct.
So usually I just write turn on the machine.
Mm-hmm.
So there are two directions to this. So the hopper will start. So this is my desired outcome. And this is my this is the function, I suppose. So this one is the desired outcome. Okay, I need to load the hopper. This one is calibrate and bring to zero because the weighing load cell is zero. Yeah, it's not zero, so I have to bring it to zero.
You calibrate that.
Yeah.
Okay.
Then after that, because we have three load cells, so the machine is ready to begin the work. So the next action for these two is here, you have to press start on the screen.
Okay.
Yeah. Then for this hopper, the hopper has reached the minimum level and the sensor is input 0.0.
Okay.
So I gave him all this information, but he couldn't do it.
Oh.
I thought I did my job already.
Yeah,
because this is
but
iteration 3 already.
Yeah, this one is
Yeah.
okay. Because this is the common one. They
Yeah.
give you because I make it a simple one. Because
Yeah.
mine is a simple program, right?
Yeah.
This is the normal one because they will have okay. If you say okay, let's say load cell make it to zero. Okay, if the load cell zero, okay, what I do? If no, what I do? Go back.
Yeah.
That's what I do. Yes, no,
This
right?
one, the load cell, this one is for the hopper.
Okay.
Hopper sensor I0.0, not yet triggered.
Yes.
That means it's below the lowest point already. So continue to output at Q0.0.
It's on.
Yeah. Then after that, has it reached? Check the highest point, input 0.1, yes. Then if it's no, continue to load, then out check against the low point. Yeah, so I thought I did my job already. Yeah, I even give them the address. This is the hexadecimal one, right?
Oh, okay.
This is that's where I learned about it, the 0x19, 0319.
Okay.
Yeah. So we'll probably cycle back to this. But it's something like this, if I were to
Yeah, you want to propose to someone something like this enough.
Yeah. This is when I started looking at the handbook. Because the microcontroller for the load cell, because they got this integrated solution, is readily on the market. It also has the RS485 connection for Modbus RTU. So I had to go through the entire thing because I had to translate. Yeah. Then all this is like basically alien language. What is 0x0319? Yeah. So then after I just go through, then I had to give him all this. Yeah.
You give him all these things, you cannot.
Still cannot. So wow.
You online or what? The source online?
Yeah, these guys are from China.
Oh.
So you have to place a small deposit, it's a token sum.
Okay.
Token sum, then they'll do this for you. Then they'll do until it's passed, then they'll take the rest of the money.
Oh.
So end up everyone was saying, okay I think it's not okay. Yeah. Horrible.
Because for me is I don't do this online. For me, I need to go there. I can do the program, okay, give you the flowchart, everything, I can do the program, but I want to test, I must come and test. Because how good you are also, when you test, there will be some bugs.
Yeah.
Because even you create your own machine also, sure will have some bugs. So you must go there and do the test it out, do the debug, everything, then only can set it.
Yeah.
Because how good you are also must sure will have a bug.
Confirm.
Okay. Now we do a program. Okay, so for the next class, you see if you want to bring any device, anything you want to bring, you can bring also.
Yeah.
If you are able to bring want to test here or load cell or something. Okay. Now what we do, so normally this is the first project I give okay, because it's a bit easier. And something similar like yesterday we do the motor 1x1 is on. But this one also say motor 1x1 is on, but we have sensors in between. Okay. then whatever we learn, we can use in the program. So let's say I have a tank, this one is like a feeding tank,
Yeah.
feed and mix, okay? Feed and mixing, and it's a very common one. Because if I give a big project, then it will consume time,
Yeah.
So what we do, so here I have a valve, and here I have a valve.
It is basically the Taubin machine really.
Oh, it's not good.
The vending machine.
Yeah,
Few component and mix.
yeah, something.
Just that no output pump.
Yeah. Mixer the pump. Okay. And okay, normally, if you go for like industry, big tank something, they will have a level transmitter to know what is the level. So normally, level transmitter is an analog input. Okay. So we haven't learned analog, right?
Oh, it's the 4 to 20
millimeter. So we haven't learned analog.
Yeah.
So what I do for this, I put a level switch.
Okay.
Okay, like a normal level switch.
Okay.
So one is the low level, one is the high level. Okay. Alright. Then this machine have start stop button. Okay. So the first IO list, you have input, we have start, stop, low level, high level. So according to our wiring diagram, according to our wiring, 0.0, 0.1 is the push button we can use for start stop. Then for low level, high level, we use the switch.
Okay.
Because we don't have an actual tag, right?
Okay.
So 0.01. So the third push button not using, 0.2 not using,
Yep.
0.3 and 0.4.
Alright.
Okay. Then for the output, valve A, valve B, mixer, Q0.0, Q0.1, okay.
Yep.
So this is the draw. So we see how it works. So very simple. When I press start, okay, I don't want to initially I don't want to do any interlocks, anything. I want to create a simple program. Once we create the program, we try to think of interlocks, everything. If the sensor suddenly on whatever and all that. Okay. So when I press start, the valve A will on. Okay. Then I start to fill from here until I reach the low level. Okay, now I'm seeing we don't have an actual tank, so you need to imagine. Okay, when I start, valve A is on now, so you just imagine. Okay, the level increase, then you just imagine. Okay, it's already reached the low level. You turn on the low level switch. Turn on the switch. Okay, I want to stop exactly here because this is for the chemical PLC. So if I want to stop exactly here means, from the moment level switch is on, from here to here, I put a timer. 10 seconds. Okay? I put a timer 10 seconds. Means very simple. When I start, valve A on, that's on finish. Then I will reach until low level. Okay. Then when the low level on, timer run. After the timer, valve A off, valve B on. Okay? Valve B on, then start to fill. So this one for maybe 50 until I reach the high level. So for valve B, no timer. Start until the high level. When I reach the high level, valve B will off, mixer will on. Okay. valve B off, mixer on, mixer run for another 10 seconds or so. Then after the mixer, the pump will on. Okay, the pump on. Then when the pump on means I start, the water will start to drop lah, right? Water level start to decrease until I reach low level. Okay, so when pump is on, what you need to, okay, imagine, okay, the water level decrease, right? So you off the high level, then you wait for a few seconds, then you off the low level. Okay, the moment I off the low level, there's some here, right? So I give like 5-second timer. Okay, 5-second timer to clear this. So after 5 seconds, then only the pump will off. Okay? So this is the flow. Now I do the flow chart. So when I press start, valve A is on. That's all finish. Okay? Then low level. Okay. When low level is on, timer VA lah, timer valve A on for 10 seconds. Then once the timer VA is done, finish, then valve A will off. Valve B is on. Okay. Now valve A off, valve B on. Then the reach high level. Okay. So when high level is on, valve B will off, then the mixer will on. Okay. Now we do a simple one lah. If this is an actual system, normally we have a small delay.
Small delay.
Delay means when VA here just put VA off, VB on, right? In
Okay.
actual system, VA off, I put 1 second or 0.5 second delay, then only VB on, something like that. It's not like that. Sometimes, depend on the system lah. But this one I make it a simple program. Okay. So mixer on. So mixer run for 10 seconds. So timer, mixer, 10 seconds. Then after the mixer 10 seconds, mixer will off, pump on. Okay. So after 10 seconds finish, mixer off, pump on. So when the pump on, what happens? The level will go down. So when low level, high level. When high level and low level both off already, I on a timer for pump, 5 seconds. When timer pump is done, then the pump will off lah, right? Okay, so I did the moment high level, low level off already, I create a timer, then after the 5 seconds, then again the pump will off.
Sounds good.
Okay, good. That's all. It done. Okay. Then for stop, okay, I make it easier, like a emergency stop lah. So when I press stop, I off all. So VA, VB, mixer, all off. Emergency stop. Okay. Good. Okay, this one is straightforward, a simple program. So later on we try to actually I didn't add any interlocks also here. Okay, I make it a simple one. If I want to add interlock also, same like this, same like that. That's not what you do. Okay. If the high level reach, it's okay. If not reach, it's still VA still running more than that the timing. VB. So normally we'll have some VB. If actual system, your VB also will have a timer. Means okay, within 20 seconds must reach the high level. If already 20 seconds not reach high level, I cut off, I give alarm. That is normal actual system you
Yeah, makes sense.
Okay, but this one I make it simple lah. Okay, you do this project. So what you do? First thing, you create a new project. You name it as a day 2 mixer project. Okay, then you add the PLC and you do the tagging first, the tag table first.
What's the Wi-Fi password here?
There, at the back there.
Aha! What is a Bobby Shan?
Yeah.
That's your colleague, right?
No. My boss pet name. Bobby.
I'm gonna order myself a coffee.
Oh.
You want a coffee?
No, I already have it.
Alright.
Nice order about
Oh, there's a fake Arabica. You know, there's this popular like viral coffee brand called Arabica, right?
Yeah, good somewhere.
So the Arabica logo is a percent.
Okay.
It's a percent. Then there's this Avenue 9%. Just get one. You sure you don't want one?
No, I had one. Thanks.
Alright. Kenangan coffee. Let's just get one. Do you think you guys want one? Yeah, it's nice. So I set up the new device, then PLC tags folder and default tag table. So from there I create all the tags.
All the these tags.
Alright.
According to this IO.
Okay, got it.
Okay. Another thing before this one.
Okay.
This one. Okay. And after that, then you can start to do the logic, right?
Yeah.
This logic you do in FC.
Oh, okay. Okay.
Don't do it OB. After this, no more programming in OB.
And yeah, actually that is correct.
That is the correct method.
Yeah, because this why I understand, right? As a beginner, I have experience in the Arduino or that.
Okay.
You call the function.
Yes.
Yeah, you don't write the entire thing inside there. Yeah, it makes sense. Yeah, okay.
So your OB will be like this. OB is the main, right?
Yeah.
Then you create a FC1. Inside here you do the tank project, and this one you call it OB.
Okay.
So later on when we add, maybe we add another FC or mess up. But I think for this project we won't add. But later maybe on the before we finish this course, we will have like this, okay? FC1, FC2.
Okay.
Then we have a function block, like a simple project, but a proper arrangement. So then only you know when to use FC, when to use FB, when to use DB.
Okay.
So
This entire one will be inside FC1.
Yes.
Okay.
That is the proper one. Yes. So you don't do, because sometimes one of my participants, what they do like half of this into FC1 and half of this into FC2.
What's the rationale for that?
Actually no need to do like that. You can do like that also, but no need, because this is one flow, right?
Yeah.
So you do inside here. But let's say this is an actual machine. You know how I will design.
Okay.
FC1 will have a tank, the flow inside here.
Yeah.
FC2, I will take the FC2. This one for the mixer and the pump. This is a motor, right?
Yeah.
The settings. You know the settings, everything to run, everything.
Yeah.
Okay. Then example now. Let's say the mixer motor and the pump is the motor, but I'm using a Modbus to communicate.
Yeah.
For example, I will create another one. FC3. This one for the Modbus program.
Oh.
So if anything happen for the motors not running properly, I go and check it. If the Modbus communication is failed, okay, always motor you see not communicating, go check it. So this is how the actual program. If I want to do a proper program for this is how I do. So let's say for this I want to create alarm. FC4. Inside here I will create all the alarms.
Wow, very clean.
This is how you do.
Very clean.
This is how you do. Okay. Don't worry, I have so many company programs I can show you how
Okay.
they design
Alright, sounds good.
all this. Some of them I go and troubleshoot, some of them my participant give also.
Okay, so stop, low level and high. So for the text, right? Like in the programming side, we don't use spacing.
Yeah, common.
So for this also the same.
You can use. So you don't use spacing, but you can put underscore.
Underscore, yeah.
You know why? This PLC can but
Yeah.
in normally programming language,
Yeah.
use C plus or that.
Yeah,
if
yeah.
you give a space, it
Yeah.
become two variables.
Correct.
Because this
Yeah.
one we call tagging.
Yeah.
In programming language, they call variables.
Yeah.
Because how I know? Because I'm not very good in the programming language. Because how I know? In Schneider and back of PLC, they use that type programming type. So the tagging all we cannot use underscore.
Yeah.
So must sorry, cannot give a space.
Spacing.
So some PLC cannot give.
So for the text is no problem.
No problem.
Okay.
You can give a tag because Siemens no issue because it's a tag.
Yeah. It's
Because-
just a phrase lah.
Yeah, so it's no issue. Depends some PLC because Siemens you can start with numbers also. One underscore what is that? If you're using LM20, you cannot start with number.
Okay.
Must put that one. LM20 cannot give a space.
Okay.
So if you want to make a space, you must give a underscore or dash.
Okay.
Because sometimes you have a long name, you cannot read properly, right?
Yeah.
Start button, if you put sometimes so start underscore button. So you want to practice that way also can, no issue. You don't want to give a space,
Yeah.
but you want to put an underscore like that, can also no issue.
Okay.
Okay, you can see this is one of my I use 1214. Okay, 14 bigger, but not so many I use. This is let me see. I put one is item, one is a normal. Inside here all the some is spare, some is this is spare. Few only. So this one is like they have you feel water, but it's like a kg like oil. Okay, you feel they will have like they will have a pallet. They will put a pallet on there will be a road cell down there. They will put a pallet. Okay, once they put the pallet, they will arrange all the waters like 25 waters, 32 waters. Okay, once they arrange, they must make it zero first the weight. Okay, then they start to fill this one. Okay, once I reach let's say I put 25 kg. Once I put 25 kg, done, must stop. The valve must off. Then they go to next. The press automatically stop. It stop like that. So this one have
the text IO one table.
yeah, so easy to
Yeah.
easy to troubleshoot. And I do IO mapping also. My input go to a memory. Then this memory I use for my program.
Okay.
So if let's say anything problem with my input, I need to go and change in the program. Just change here is enough.
Okay.
Because this input represents this memory. And then for output also got this here, the outputs. So in the program, in the process, this is the process. So I put one, so this one is for the neck weight, cut weight, and this one is the offset, this one is the start the feeding, this is the everything, then feeding, so each one got their own, so I make it, I mark here,
Yeah.
easy for me.
Yeah.
The names also, you see, it's very common, memory cut off, okay, all that. Then here is the communication setting. So Modbus. So inside here is for the Modbus setting. That's not finished. So if anything problem, I go and troubleshoot here. Then they have values 31, 32 pales where I see. So I need to move the value according to that. Then I see. Because they have a pallet, so they have how many pallet? 25 pallets. So one pallet, 32 pin. So you must have 25 pallets. All the pallet data I move to the DB. That is actually the function of the DB.
To store the data.
To store the data. Can you see I put the retain? Retain. And for this I use the WinTech. So once one is finished already, so one pallet is finished, all the data from the weight will go to the pallet one. So my graphic is like this.
Hey, easy build pro. Yeah. I have it in the laptop also.
Yeah, I use this one. Very user friendly. And when I do this project, I learn a lot of things.
Okay.
Yes. Because normally I do a simple one. So this is so here we can add the products. How many products they want. And you select the products. Once the select done, then this is the way.
So the data will be locked here.
Yes. So you just press start only. Actually is a normally they will have a button there. They start to fill. Here will be a target value. Okay. Number of pay. Once I finish the level, okay, finish. Once I reach, then it will go and mark here. Then go to here.
Also 32
Pills.
pills per pallet.
Per pallet.
Oh, okay.
Once I finish, all this data will go to my the DB. Pallet 1. Once I finish pallet 1, then all becomes 0. Then here become pallet number. When pallet number 2 becomes 0. Then here will be the number of pallets over here. Number of AA is because they have a pail or drum, so we can change. Once they choose, it will automatically change. Oh, this one very difficult project for me because time consuming.
Yeah, I see like all the one network, 20 networks just not the one.
Only that one only higher. The rest is very small. Because only the process because the others all like total weight you see. Just all look like very big, but you see all same just total weight. So all I calculate but this program, and actually if you see this program, it's the same thing. The only thing is like two different pallets. I mean different pallet number 25. Then pallet number 24. It's the same thing, just but the problem part is this one. You need to take one by one and only the programming is programming I see. This is the difficult part. The rest is like example the move the value, all that just moving.
Yeah, my code is very clean.
So I make sure easy to understand for me so later because after like 2 months, 3 months they call me again.
Yeah.
I can of course I will forget on the flow. So I need to check it. So that's why I put a proper names and everything.
Yeah. So that's not good.
Yeah. project lah.
Yeah.
I cannot issue company project also.
Yeah, talk about that's not like this.
Yeah. Yeah. I just want to show, just want to give you some idea
Yeah.
how to arrange the program.
Yeah. But maybe after that still, I need to understand like just you show all the function block, right? So it's supposed to be like they will call that all the functions in one scan. They will call all the functions from top to bottom.
Yes.
Yeah. Like do this one first. Maybe I understand that later.
If you see, and just now I said, right, I put number 01 mapping, 02 is the com setting, 03 something. I put number, right?
Yeah.
Actually, I get this idea all from company machines. All these I do, right?
As in the start button.
No, not start button.
Is the
Not
10.1.
That one,
Yeah.
that one also I learned from when I go troubleshoot. I say, what
Yeah.
they do, IO mapping. Okay, I get the inspiration. And if you see the FC name, right, I put okay, 01 Modbus, 02 10, because I arrange my program.
Okay.
That one also, actually the number is nothing, just put Modbus, 10 is okay, but want to arrange properly,
Yeah.
you can put number, so it look clean.
Yeah, it looks very clean.
This one, only once I finish everything, I want to give it to them, then only I put the numbers.
Oh.
Before that, I just put clean. Once I finish, the last one lah, I just need to tidy up all the mess you create, everything. Then that time only I put all the numbers properly lah. Because when you want to make sure it's look like professional.
Yeah.
And if you see also, if I use capital means all capital.
Yeah.
If I mix means capital and small letter, all capital and small letter. I don't like to mix capital and
Yeah, it looks like you take from here and just pump inside, right? Yeah, I cannot. Yeah. Also learn on the job.
Yeah, of course. 10 years.
10 years? Wow, no wonder.
10 years here. Because I joined in 2016 actually.
Wow.
Yesterday wrong, it got at 15 mistake. 2016 after finish my diploma, I actually don't have the plan to come here. I don't know this company exists also.
Okay.
Actually my cousin sister was doing accounts for this company. So that time before me, there's 4 guys work here. One guy come work, that time my boss do training and project. Then company see this guy do project, that company will take him. Then my uncle, my boss will take another guy. Okay, he come. Then he go and do some project, that company see him, he take them. Like that. So before me there's 4 guys work here. All like 1 year, maximum 1 year.
Kena poach lah.
So maximum 1 year. So after just finish my diploma, I just already applied for degree. Then I wait for like I have a time like 2+ months. Just after 2 weeks, cousin sister called me. Hey, you can. I know this uncle. Do you want to come and help this uncle? Because currently this uncle. Because that time his son is. Yogesh is my boss' son. So he was working in Indonesia. Then my cousin sister called me. Can you help this uncle? Until in the meantime he find someone. I said okay. I just want to come here and work.
Yeah.
Because I'm from Perak. So come here work, can earn some money, can go for degree.
Perak is the one near the border, right? Is it?
No. Yeah. There's a type. There's one way to go to the border also lah. But after KL lah.
Yeah.
After KL. So I come here, I work, then I start to, because the main thing is I like to use computer. Because PLC must use computer.
Yeah.
Right? Then I like to do hands-on work. Like house electrical, I like to do my own. I mean, repair simple lah. Then I come here, then the guys who come for training, because I'm from mechanical background. But here I learn electrical, right? They say, okay, very good, because from mechanical background. But here I learn electrical.
Mechatronic that's
Like
very
mechatronic
different.
lah. So they brainwash me, you say, okay, good future. Then I will get a scholarship for degree in Nila University. Then I decide want to go there or not want to go there. But if I go for the scholarship, if I go, it's okay, but I will miss this opportunity. Because over the 3 months, right, I go give training, all big company, Samsung, Dyson, another company here, I forget. Kiswire. So all the three 3 months, I go to these companies give training. So I know, okay, all the companies using PLC.
Yeah.
So and they come in here to learn means in their company nobody know the PLC. Means the demand is high, but
Yeah.
there's no people to do PLC.
Yeah.
Then only okay I know. Then only I decide okay never mind, I don't want to do. I don't want to do it. I didn't accept the scholarship. I said okay never mind. Then I check here in India for part time. Then I go and join part time. Then only I say, if my sister didn't call me, then I won't be here.
10 years of learning and still learning.
Yeah, of course,
Yeah.
learning.
And still
Because PLC is endless. Because in industrial automation, PLC is just one part only.
yeah.
Automation is very big. Because you have for PLC, you have for HMI, you have for SCADA,
Yeah.
you have for cloud service, you have for OPC, so many things.
OPC is what?
OPC is like a similar concept. Concept is similar to Modbus.
Okay.
Means I have this device, they don't know, cannot communicate each other using their own communication, so they use Modbus to communicate, right?
Okay.
Something like that. OPC means PLC communicate to like a cloud, SCADA, SQL,
Okay.
all that.
Also, they actually break the chain of the. I think there's
Between
like
the softwares.
I think there's like a 32 unit limit, right, for Modbus RTU.
Yeah.
So it breaks this lah. There's no longer
Yeah.
32 because using the OPC over the cloud.
Yeah.
Oh,
So it's an open platform communication.
interesting.
So this one can communicate between the software, normally not between device. Between device normally like Modbus. Between softwares. Send data to database, send data to SQL, send data to cloud, all that use OPC.
Wow. So those guys are making a lot of money.
Yeah. OPC, you know the OPC license itself,
Yeah.
depend on number of data you want to send. So I know normally common one I use like Capware, they call Capware. But for training also I use, because you know why? For training, that software is free for 2 hours. After 2 hours you can restart again, free for 2 hours. But if you want to use for actual system, cannot free, because always must send data.
Yeah.
Because after 2 hours you will stop the sending data. So for training I use that lah. But for that, if you want to buy for Siemens, the number of tabs I think is if you buy for 2000 tabs, 2046 tabs, I think it's 9,000 ringgit.
9,000 ringgit per month.
I think
Or forever.
per year or one time, I'm not sure lah. One time I think. But normally company won't be like 2,000 tabs, maybe
Yeah.
more than that.
Oh, is it really?
Yeah.
For the entire factory lah.
Yeah, definitely lah.
Yeah.
And sometimes some company they have one SCADA, but PLC are different model. So for Omron they buy one OPC.
What
For
the-
Siemens they buy one OPC.
Why would they use different PLC?
Yeah. No, that one is initially they buy this system. Okay, Siemens. Okay, initially buy this one. So when
So
they want
over
to
time they accumulate the machine.
accumulate, then over the time okay, they want to centralize this, and then they have a difficult. So because it's different. And sometimes you want to buy a machine like Siemens, but you see the maker don't use Siemens. You cannot do anything. They say the maker only use Omron. You must buy Omron. No issue, no problem. No.
Wow.
So you cannot do anything.
Actually now there's a lot of disruption coming from the China market. Like the day I was looking at the inventory app on my phone. So inside the app store so I see like there's this called Stockly, there's this called what's it so it's basically to take stock, take inventory shortly and took stock inventory tracker all this
Okay.
So these guys are charging about $12 US to $15 US per month. So you pay a year, they give you like a 10% off, for example. So then after I go to Douyin, remember I told you the original version of TikTok.
Okay.
So on Douyin, right, so you can search for in Chinese, you search, I need to take stock, I need to keep track of my stock.
Yeah.
So then they give you all the recommendation. Per year, the price is equivalent to 1 month the price. So I'm quite sure the OPC or that, they also have similar things.
Yeah, of course.
Yeah.
Sure they have.
Yeah. So the competition for all this really heating up.
Yeah.
Yeah.
That's why I say, China market is very.
Because now in Singapore, right, they are also, like let's say the craftsmen, they build the cabinet in the HDB, they come down from China.
Oh.
Yeah. The foreman, basically, the foreman is the business owner now. Then he get his fellow colleagues from China to fly in here. Yeah, then he hire them because the foreman opened a company. Yeah, so these guys will go down to the HDB, build the cabinet on the site. Yeah, so usually what happens is the Singapore ID will design the cabinet already, send the schematic to Malaysia. They assemble everything here, ship in one lorry, then they assemble there. The Chinaman cut on the spot in the HDB. Damn fast.
Yeah.
The manufacturing happens in the house. Yeah. So instead of, so they don't waste money buying material in JB and trucking it in.
Yes.
Yeah. They buy wholesale plywood, go to the house, laminate on the spot, cut on the spot, install. Yeah.
In Malaysia also same.
You mean the Chinaman is here as well?
I'm not about from China, but Indonesia.
Yeah.
You see, last time the house construction work, the boss will be Indian, Chinese, or Malay. The workers will be some Malaysians, and the laborers normally will be the Indonesians.
Yeah.
Now, if you go to KL someplace, the boss is the Indonesian guy, the boss. So what happened? And sometimes the seller of the material also, the company boss also is an Indonesian guy. So he get a cheaper price from the Indonesian seller for the materials. He buy. His worker are Indonesians. Okay. So if you compare their price and a normal Chinese or Indian boss, the price is like 75% difference.
Oh.
25% off already here.
Yeah.
So why not I need to pay 25% extra? Make them, they will come here every day, they will work here every day. They will work day and night. They will finish very fast.
So it's legal one.
Of course not legal. Because I saw, because one time I go to my cousin uncle's house. His area is here. In front of their housing area, there's a front here. This area is very high profile area. Then he showed me one house. It's a 3-story or 4-story house. The owner is Indonesian guy.
Okay.
Indonesian guy. He said last time he worked as a contractor. After, because so you know already from where you buy material, everything. So like you say, he know already the business. So now what he do? Okay, he open up his home. Then if any project, he bring his guys from Indonesia. He do very fast, finish very fast, very nice finishing everything.
Yeah.
Same thing lah.
Yeah.
Now it's very competitive.
Damn competitive. The app, the one like 1 month pay for 1 year, not 5.
Yeah.
Yeah. But the middleman, we can try to be the middleman.
Yeah.
Because there's a lot of people in Malaysia that don't know how to read Chinese, for example.
Yeah.
Yeah, so we will just bring in whatever it is, then we offer this service to them.
Yeah.
Yeah. So here still the market is damn big. The population is about 5 times of Singapore.
Malaysia.
Yeah.
Yeah.
Yeah, it's big. Then the trend for JB is people are moving into apartments.
Right?
People are moving into apartments.
Yeah.
So from the landed, they are moving into apartments. Yeah, so they are going to face a lot of the challenges that Singaporeans are facing.
Yeah.
We are staying in smaller houses. Yeah, so there's a lot of smart solutions that can be offered to them.
Yeah, of course.
Yeah, that's why we're moving into the e-commerce for JB as well.
Oh.
Yeah. A lot of solutions. Like even the shower head, for example. The water tank actually is quite a bit. So the entire house, right, the water, right, can be filtered by those kind of water filter, right?
Yeah.
Then the shower head also got the same concept, right?
Yeah, same concept.
Yeah. So there's a filter inside the shower.
Inside the shower.
Yeah. So that one also sells quite well.
Yeah.
Because that one is actually quite tricky. So the handle is transparent, you saw it before?
Yeah.
Then you see the thing start to change color, wow, this thing works.
Yeah, that's the thing.
Yeah. Then for the home cabinets, right, we also offer this product, it's a formaldehyde remover. You know about the formaldehyde? So for the glue, right, you know the plywood and laminate, right? So they brush on the contact cement, right?
Okay.
Then after that once dry, then they whack it together and roll it.
Okay.
So that's the laminate finish already.
Yeah.
So this one, right, actually has a lot of formaldehyde inside. It's a kind of chemical, it's bad for health one, bad for kids, everything. Yeah, it's cancer causing.
Yeah.
So, but this one is good. This one is good in a sense that it's very sticky.
Okay.
Yeah, you see those old laminate, the cabinet, right? The laminate don't come out one.
Yeah.
Nowadays they use less of this, they use a greener option. So the laminate sometimes you see like Yeah, so the formula serves the purpose, but it's bad for health. But there is a way to remove it using our product. Yeah. So with all the built-up environment in JB, right? So this is one of the things that we're offering as well. Yeah. So
What's the company name?
Agion Tax.
What's that?
AGION.
AGION.
TX. Yeah, but we are moving in. We are moving in. We are doing this in Singapore. Yeah.
Do you prefer home living products?
Yeah, so
Shopee also,
yeah, we're moving into the Malaysian market. Yeah. But we are not just going to sell this. There's so many things to do in Malaysia. Some things that we never thought of doing in Singapore.
Yeah.
So many things to do. I mean, there's so much land.
Yeah, it's correct.
You know the rental that we are paying here, right? Is equivalent to almost 4 times the space that we're getting in Singapore. We are talking about just the land area, not the built-up area. The place that we got, we can do a second level and third level. Yeah. Because the ceiling is very high.
Yeah.
To reach the stupid land on top, we need to do a scaffolding. It's that high.
I know.
So yeah, we are at least getting 3 times the money's worth. Yeah, here. And I can basically stay inside the factory. Because it's very safe. It's a gated community. Yeah. And the place at night very nice. Because Singapore, everywhere also street light. Everywhere also got camera. Everywhere also got building. You open the window only you see your neighbor already. Yeah. So you feel like they say Singapore house like pigeonhole. Yeah. But it's not as bad as Hong Kong.
Hong Kong.
You've been inside one of those Hong Kong flats before. Okay, so my client they invite us to the house. Then I saw the kitchen, right? Usually like got a stove there, then after that behind me your fridge or whatever, right? Wow, I cannot walk past my client when she's cooking. Yeah, it's that small. That means basically she stand there and she cook, then she turn around and use the basin, then turn back, then she cook. I cannot walk behind her. Then they don't allow gas or induction. Yeah. Then once she cook, right, the entire house also the smell. Yeah, it's very small. Yeah, very small. Then the room, right, damn sad. You put one personal bed, full already. I don't know how they can allow this kind of thing to happen.
It's maybe the population there.
Yeah, because I can understand why, but it should never have gone to there. Even the condo they buy, all there is condo, there's very little public housing. So the condo, you buy the house. If you have a car, right, you have to buy a parking lot. Yeah, it's not the same here, right?
No.
Yeah.
Because my house is
It's shared by everybody, right?
Yeah, it's shared, but they will give you one lot for you.
A sign lot.
One sign lot. Then one common one.
Yeah, so there, same in Taiwan also. You buy the house. So what people do is they buy more lots. They buy the lots, so it becomes like investment also.
Yeah, then they can give a rent.
Yeah, correct. So they buy up all the lots. So the people, it's not that they got no money. They got no access because the guy in front took all the lots already. So the poor bastards that bought the house have to rent the lot from them.
Yeah.
Yeah. too competitive really. Yeah, so like when we come here, I feel like the pace of life here is quite good.
Yeah, still.
It's quite good. Yeah, it's quite good. Okay. Let's get back on track. But yeah, we're gonna need some help with the machine.
Yeah.
Yeah. Actually, how do you frame this graph set? So, like the line is start. So it's an action from.
Yeah, it's a condition. Yeah.
It's a condition as in.
Condition means it's like maybe it means condition means like you read the tag, you read from the start button. Means I press or I release the sensor on, or then what are the action I need to do is the square one.
Okay.
It's the action. So this is the condition what I need to do. These are the action what I do. This one.
Oh, so you wait on the condition, and then the action is the after effect.
Yes.
Right. So you wait on the start.
Yeah.
Okay.
So I press start.
Yeah.
Okay,
Then something will happen with
yes.
on.
Then
you
low
wait.
level on. Okay, what happened?
So there is basically the line is the detect part lah.
Yeah.
Okay. Wow, better write this down. Better write this down.
Yeah.
Oh yeah. Let me have a look what's going on again with Grab. Mr. Hamiro is on his way. Alright. Then he ordered Udo. He's supposed to arrive 12 to 12:30. Yeah. But the delivery the experience so far with the delivery has been quite bad. Yeah. The Grab travel is not a problem, but the delivery is the problem. Yeah. Nobody is keeping to their timeline. Yeah. It's quite bad. I mean, like, how difficult can it be, right? It's not like it's raining. If it's raining, okay, I can understand. Yesterday, my wife was doing her nails. So I was talking to the lady boss. Then she also said the same problem. Because like yesterday, I was a bit tired, so I decided to go out to eat lunch. So I just ordered in and I take a nap. Then 1 hour later, then they notify me order cancelled. Nothing came. No compensation, no communication. They just return you the money, okay, go. Yeah, so it's strange. But they have reached a critical mass that they can do this. What are you going to do about it? Just let me figure this out, because I have a few ideas, but I don't make it too complicated. Like your that input output mapping, right? Very good idea. Yeah, very good idea. But I just follow this flow.
This first, yes.
I just follow this flow.
Yes.
Yeah. I put the wrong address.
Oh.
For this one for the coffee order. I don't know why they tag me as at the morning breakfast place.
You ordered there or what?
No, I ordered here.
Oh.
Yeah. Second.
Why the guy go there?
Yeah, the guy go there and I see that, hey shit, something's wrong. Then I asked him I asked him like, hey, I just send you the tips then he tell me how much, then I pay extra but he must remember to take the photo there. Yeah. Then he complete his mission
Yeah.
Later he had to study and go back again. Just how I got the thing to work, but then after that, the pump 2 didn't turn off, the valve B.
Oh.
Just now I forget to put the function block inside the OB block.
FC inside the OB,
Yeah.
So it won't work.
Yeah, it won't work. I was like, hey, how come nothing going on? Yeah, okay, yeah, let's drag in. Oh yeah. Okay, so the mixer is off already. So valve A after 10 seconds, when it reach the low level, off. Then once off, valve B come on.
Yes.
Then it will come on until the high level reach.
Yes.
Then after that, the valve B will off. Valve mixer immediately turn on
Yes.
for 10 seconds. then after 10 seconds mixer will cut off. But the the high level and the pump on that one. So the pump on high level and low level off. Then pump for 5 seconds. That one I don't know how to do because I think on top right I did it too sketchily already. Too sketchily already. Quite satisfying. Standard start. Once you press the start,
Valve A on. Okay, good.
yeah, all A on, then latch it.
Okay.
Yeah, so I latch it, then we go here.
Low level.
Yeah, low level.
Timer. After the timer. Low level cut off. Okay, here.
Yeah.
Valve B set. Okay, go down.
So I use a memory to track this.
Okay. And high level. Valve B reset. And high detector. Okay, go down. When high detector. It's on. You use TOF. Okay.
Yeah.
TOF here carries because if I use a TOF, if I want to stop, right, can also can, okay, that means can also mixer, then once the mixer is off, then the pump on, right?
Yep.
So if I use TOF, then I cannot get the mixer timer, right? The mixer timer.
If the mixer timer off,
The output.
yeah.
So I think you can use the TON
Yeah.
easier. So when high detected, I on the mixer,
Yeah.
then mixer will on the TON, and after that I use the TON to off the mixer and use the same TON to on the pump.
Wait, so high detected, then
Then high detected on the mixer directly. Same like the start.
so then after there will be another one lah.
Another one for the timer.
Oh.
Same like the previous motor we do.
Okay.
Same like I think your graph is already here.
Oh, is it?
I don't know. You check and see.
The message from the wife.
Oh, okay. What's the number?
See, 8964. It's a bike, it's a Honda Wave.
8964, yeah, it's in the stats.
Wow, what a nice guy.
Okay, I will explain why.
Yeah.
Okay, can I erase this part?
Yeah, I already inside the thing already. I remember all this. Yeah. Yeah, I was thinking how to chain the next one. So actually I did a shortcut.
Yeah. So it's okay.
Yeah, if it ended here, it will be fine.
But okay, there's two problems here.
Okay.
The first one is because the high detected is okay lah. Okay, the high detected, and I use a TOF mixer. It's okay, it's correct, no issue. But there's two problems. One is because after mixer off, I want to on the pump.
Yeah.
Still can do, you know how? Because the idea is when mixer off, I want to on the pump.
Okay.
Correct?
Yeah.
So I can use the end of the mixer. Correct?
Yeah, makes sense.
Negative pulse of the mixer on the pump. But I must put a condition. Why condition? Because if let's say suddenly automatically the mixer on, correct?
Yeah.
Suddenly the mixer on and I off, then the pump will automatically on, correct? So what I can do, I can put some condition, that is the high level and low level must be in on condition. So when mixer is off, I get the pulse and I make sure the high level and low level is means there's the water is still there, right?
Yeah.
The pump is on. Okay. Then I latch it, but latching must be after the this on. Why? Because this is a pulse, right? Okay. Then when the pump is on, the level will drop, high level will off, and low level also will off.
Yeah, so the latch cannot
So
be
the pump need to be still on for another 5 seconds, correct?
Yeah.
So I put it here. But the problem is if I want to press stop button here, right?
Yeah.
If I want to stop, I cannot put the stop here. You know why? Because when the timer is still running, you press the stop, of course it will cut off this. But when you release, it will on back the mixer.
Oh, because the okay.
Because I cannot reset the TOF.
Yeah.
If a TON means, example, if the TON means if I off this, it will cut off.
Yeah, you stop counting up and reset.
So can. Or if you want to use the TOF, still can like this way. What you do like this.
It's so complicated.
But what you need to do? You need to create a stop and a memory and a latch it. Means I make sure when I press stop, the memory is like always on. This is the push button, right?
Yep.
When I press, I on the memory, I make sure the memory is like always on. I use this memory here.
But this is not a best practice,
Yes.
You still can make it work.
Still can make
Yeah,
it work.
still can
but
make
not
it
the
work.
best practice.
Yeah, but not best practice, okay.
If I use the TON, okay?
Yeah. TON.
So when high is detected, I straight away on the mixer.
Okay.
I just follow this, you know. High detected on the mixer. Okay. Then the same high level on the timer. But my high detected is a pulse already. You already use it at the pulse, right? So what I do, I use the mixer. Same like the normal program. Like start, motor on, motor timer, right? So here I will have a memory. I use this memory is this, right?
Yep.
So this one will off the mixer. So this one will off the mixer.
Okay.
And this one
Oh,
will on the
okay.
pump. So memory on the pump.
Okay.
So later you think whether you need to latch or not. Okay, according to this, it looks like they're latching. Okay, latch. Let's follow the flow.
Yeah, better. This much better. Because
That's
just now
like-
I make a problem, then you have the solution for the problem.
Yes.
Yeah.
So I say, logic, you can create many ways to make it.
Yeah.
To make it run, there's many ways. You can do in 5 networks to run this program, or you do in 10 networks to run this program.
Yeah.
You know?
Yeah.
But there's nothing such like, okay, 5 network means it's good, 10 network means it's not good, not like that. And if the machine can run or not, if the machine can run, then it's okay. So the number of network is no matter, there's no problem here. Okay? How you want to program, then make sure it's easy to troubleshoot and easy to understand. That's all. The TOF you can use for this time.
Okay.
But still for this also, that's the only problem with TOF. Because TOF, you on the high level, you just
It's
on,
on
the
already.
Okay, off. Okay, you on again. You see, it's running, right?
Yeah.
If you put the normally close here,
Yeah.
if you press, if you cut off here only, this one will cut off. But still running only.
Yeah.
That's the problem with TP and TOF.
TP is what?
TP is same like this pulse. Actually, you can use TOF or TP also can.
Yeah.
Here. In this case lah.
Okay.
Because it's a pulse only, right?
Yep.
So in TP or TOF. TOF and TP, that's the problem. The output will be always on for the time period.
Okay.
Only TON you can reset it.
Yeah.
So that's the thing. That's why normally machine also they mostly use TON.
UL.
TOF, TP is just a depend on that situation. Okay, then I can use.
Okay.
Okay, right.
and I named it timer mixer off. But I deleted that block already.
Okay.
That's the one that I named for the TOF.
Okay.
Where do I find that tag?
Okay. It's here.
Technology?
It's not under system, no?
System block.
Program resources.
Oh yeah, okay.
So
Okay.
you just drag and then put it. So
okay.
if you remember the DB2, right? You can put DB2.
Oh, okay.
Actually, the TOF, right? You double click the TOF. You can change.
Okay, okay. Yeah, this one. I just dragged it in just now.
Yeah, that's right. You can change also. Yes.
Right. So right now my pump is on.
Okay, good.
So I use the low level cut off and the high level detected memory to track this 5 seconds.
Okay.
Yeah, but the thing is, because on top, right, I use the set.
Go up.
Sorry, not that. Yeah, so this one. So they already set the high level detector is set already, ma.
Mm-hmm.
How come the below here is not set?
It's set what? Because you're using normally closed, right? It's already open, right?
Right.
So what you do, actually yours is okay. But in small changes only.
Yeah.
You go up,
Yeah.
first go up, because you go up some more. Okay, because you see high level detected, you use here, right?
Correct.
So since you're using latching, right?
Yeah.
So you don't need to set this one. Normal coil is okay. So if you're using normal coil here, so this one will become pulse, here also become pulse, correct?
Correct.
So when this one become pulse, so this one also become pulse and on the mixer.
Oh yeah. Okay.
So just a pulse enough to on the mixer. You go down. When this one is on the mixer, so I don't need to set this one. Because of this one is always on, you set this, correct?
This one is always on.
Yeah.
Correct.
So because of this one is always on, you set this one. If no, if this one is like a normal coil only, right?
Yeah.
The timer will repeat. Because this one is always on.
Yes, correct. So it's always on here, right?
Always on here, right? Actually not necessarily.
So if this one become a pulse, then here latching already.
Latching,
right?
yeah. So here latching, so the
Yeah.
mixer will run after the timer, then this memory can cut off the mixer. Okay? You go down, when this memory cut off the mixer, go down, I use back the same memory to on the pump.
To latch again. Okay.
Yeah, let's start because this one is memory right from here.
Why did I do that?
No need to set actually here. Because if you set, can, but need to reset. But when you want to reset it?
Okay. Why I did that, right? Because I wanted to use the thing here.
No, you can straight away use the high level one.
That means I use a different memory.
I know, okay. Okay, no problem. You can still use the high detected, but when to reset it? Because you set something means you need to reset it.
I was intending to set it once the pump off.
No.
Then
Because
we
if you want to do that, then this one you can use it.
yeah.
Because what your logic is when the pump off, then only I want to reset this memory.
Yeah.
So I cannot use here.
Okay.
So what you can do, actually the set is okay, but if you want to reset it, after the mixer timer, I can reset it, but no need that memory. So in that case, you go down. Here you can use the straight away the low level and high level. No need to use the memory here.
Okay. normally open?
No. Because when both off, then only the time start, right? So actually normally close is correct here.
When the pump is on,
When pump is on,
I need to
high level will off first. Okay, now you off the high level first.
Off already. Both are off.
Both are off, but you see it's not off here.
Yeah.
Why? You go up and see. Because you go up. For high level on, you make it a pulse. So high level off, you need to off this. You go up for the low level, where's the low level? Low level off. So I also need to reset.
Yeah, the thinking wrong already.
No, yours is okay. The thing is need to think when to reset this.
I want to reset it when I finish this loop.
Okay, can. If you want to do it that way, go down. So you can use the memory here already. Because what you plan is, your idea is, okay, you see, I just explain here, inside here.
Okay.
So, after the low level timer, here you create a memory, M1 for example. You set one M1 lah, correct? Memory, Correct?
Alright.
Okay. Then, when high level on, you set memory 2. Okay? Your idea is, you want to reset these two memory after this, correct?
Correct.
So, here you cannot use these two memory as an interlock here. Logic or not?
Yeah. So when these two are set ready,
Set
right?
ready, it means it's always on.
Correct. So these two are like checkpoints for me lah.
Okay, can.
Yeah. So my high level is on, then the low level is on. Then you say I can use where?
No.
I cannot.
Your idea is, okay, this is the first process done.
Yeah.
Second process
Yes.
done.
Yes.
Okay. You want to reset this after the pump is off, correct?
Correct.
You want to reset it here, correct?
Correct.
M1 and M2. So you cannot use these two memory as a condition to the timer.
Oh yeah, because it's not off, right?
Yeah, because it's not off.
Yeah. Okay. Yeah.
So to enable this timer, you need to use another memory or the high level, low level.
Oh, okay. Wrong already. No, okay.
Your idea is correct, but the thing is, your idea is okay. Condition, okay. The first process done, then only I can go to here. Second process done, then only I can go to here.
So maybe instead of setting that, I need to create another memory to track the process done.
Can, but your idea is okay. But here, according to this one is okay because the first condition, first process done, then only the VB can on, right?
Yeah.
Then when high level on, then only the VB can off, mixer can on. So until here, correct? Okay. Then after the timer, pump on, correct? To on the pump, okay. I know your condition, okay. If you want to use this as a condition, you can put these two here for the pump. Means first process is done, high is detected, and the mixer I get the data, then only I reset the pump.
Yeah.
So then only I on the pump. I can put the condition here.
Okay.
Okay, but to off the pump, I don't need the condition. I don't need the process condition. I need the actual sensors. Then only I can off the pump.
Okay. I thought about this also. Because when you start the machine, right? Because everything is off, the pump is already off, so it won't trigger also. Yeah. So there's nothing to cut off.
Yes.
Yeah. So that means correct, your logic is correct. So that means I can still use the inputs for the low level, high level.
Yes.
Then when I need to turn on the pump that time, right? These two will also be on.
Yes.
Yeah.
You can use here.
Yeah. concerned about, you know, when the machine just start.
No, that's your problem.
Yeah.
No, don't. Whenever you first write a program,
Yeah.
don't ever think about that one.
Yeah.
You write your normal flow first.
Yeah.
From there, we try to modify.
Yeah.
Then we think about, okay, if suddenly the sensor is not working, what I do? If suddenly the low level not detected, straight away high level detected, what I do? Then it's secondary.
Yeah.
First, you need to create a flow first.
Yeah.
Because in the first flow, you already go and do this. Okay, process 1, process 2, you will start there. So you don't have time to think, okay, how to solve the issue. First, you try to run first the machine. Okay, then only you think about, okay, if the start, but let's say for example, you run first this one. Then only we think about, okay, if the low level is not detected, what I do? Or suddenly low level detected, what I do? Suddenly high level detect, what I do? Okay, and you, of course, this machine you need some other inputs as well. Additional inputs you still need, but I didn't add all the inputs because for the pump you need to input pump trick, motor trick, etc. All that I didn't add. So this from these two level, we can try and see. Before I press start, suddenly low level trigger. What happened? You run the timer. After that, what be automatically on, right?
Yeah.
So I need to think. Okay, once I create a program, then only I think, okay, how to solve this issue. So what you can do, these two you directly change to low level and high level.
Yeah, correct.
Then pump off. At the same time, you reset these two memory. Because these two memory you set on top.
Yeah. Oh, so my method will still work lah.
Still work, that's why I say
Yeah,
your method
yeah.
still work. But the thing is, you need to reset after here. Since you are resetting after the pump off, I cannot use these two memory as a condition to on the pump.
Yeah, I understand. Yeah. Oh, this one.
Because you see now low level, high level off already, right? It didn't trigger the timer. Right?
Yeah. Correct.
stop also, you need to reset that. Put it back.
Hello. You arrived already, huh? Sorry, I can't speak Malay. You collect already, huh? Ah. Ah. Yeah, I think I need to.
Wait.
Yeah.
Think first.
Yeah.
Why it's repeating? After this, you go up. You're supposed to cut off this, correct?
Yeah, the pump should be off.
Off, right?
Because I trigger from
Trigger here should off. Okay, it's actually off. That's why reset. Actually, your pump is off. That's why it's reset. Okay, but why cannot off?
Because the mixer off is set.
This memory is on, so you need to reset this memory also.
Here?
Ah.
Wait, so the logic is correct already lah, but it's just
That's it.
that I didn't.
You straight away. Okay, if you see there's a problem here, don't overthink. Okay,
Yeah,
you need to
yeah,
cut
yeah.
off this. Not here. Why? You need to find out why it's repeating. Repeating means this line is actually already off and on back. So this is the sensor. So sensor means if you touch the sensor, then only it will off. Means the signal is by the pump. Why the pump is off and on? You go and troubleshoot here. So this is how you troubleshoot as well. So now you add the mixer off.
Hey.
Can.
Yeah.
Okay, the stop.
Stop not yet inside. So technically I can press the start again now, it will start again.
Yeah, of course. You go up.
Everything is off already lah.
Okay, you start.
Yeah, then the cycle will repeat already lah. So actually this loop is complete already.
Yes, low level. You try again. Low level on.
Yeah.
Okay, go down. Okay, valve B on. Okay, high level on. You go up.
And the mixer is on. Now the pump is on.
Yeah. Pump is on.
So
Okay.
turn off the high level.
High level first. Low level. Okay.
Then you pump down. Then reset everything.
Reset everything.
Yeah.
Yep.
So the loop is done.
Yes.
Yay! Now we just have to put in the stop.
Yeah.
As long as I hold down the stop button, everything stops.
Okay. Go up.
Yeah.
Where you stop?
I added in all the triggers.
Okay. You make the mistakes. That's
Awesome.
why. There's the mistakes. Okay. You take out.
Alright.
First mistake. Low level cut off. Where is the low level cut off? This one, right?
Yeah.
You need to reset, right?
Yeah.
But you call
Okay.
reset. Correct. When you stop, you want to reset it, right?
Oh.
Got what I mean? No, you don't see this. Don't see here. Go down.
No, that means I took the wrong thing already.
No, you
I know.
want to reset, right? No one.
No, I think my concept is not right from the structure part. Why did I say this? I thought I took it from here, is it? So if that one is on, this one is broken, ma.
No. Okay, I will tell you. You didn't follow this. Did you follow this or not?
Valve A of no leh. But how do I get the
No, very simple. You see here.
Yeah.
When I stop, valve A, valve B, mixer, pump. Any one of these on must off. That is the condition, correct?
correct?
Right, that is the flow here. The flow chart. Here you go up. If valve A on here,
Yeah.
how am I going to off this?
It's kept on by this loop.
No. Who actually on this?
Itself.
No. Start button, correct? I press the start, valve A is on, correct?
I press the start button to latch
Valve A on.
Yeah.
And I latch it.
Yeah.
If I want to off this, I need to cut
Break.
off the line.
Ah.
So put a stop here. Why you put this one here?
This one is from the bottom here.
No,
To break.
not from the bottom. This one is actually after the timer.
Yeah, after the timer to
Yes.
unlatch it.
No. After the timer, you put it here to cut off the valve in.
Correct.
Correct. Same thing. Put beside the stop button. Put it here, the stop button.
Okay, that's true.
Huh?
That's true.
That's the
Okay.
logic.
Yeah. Okay.
Okay. That's what I say. One by one you do.
Okay.
Put the stop button there.
Do I need to unmonitor first?
No need, because if you click normally close here, it automatically become, you put it normally close here,
Alright.
automatically go offline already.
Ah.
Okay, so no worries, stop. Okay, now where is valve B?
Valve B set.
No, here. This is valve B, right?
Okay.
Correct.
Yeah.
Okay, if I want to off this, what I need to do? Need to cut off the line, correct?
Yeah.
Okay. But I see this one is a set. So I need to reset it.
Okay.
Right. Okay. Go down. Go all the way down.
Where I put the reset?
Reset this one. It's correct.
Okay.
Okay. Go up. Valve B is done.
I delete this first.
Okay. Delete.
Yeah.
Okay. Go up.
So the next one.
Valve B is done. Next mixer. Where is mixer?
Mixer is
Here. Go up slowly.
oh, okay.
No,
So
go up slowly. Okay.
okay.
Mixer. If I want to off the mixer, I need to cut off this, correct?
Correct.
But high detected is always on, right? So I need to, if I reset this and also off this,
Okay.
so here I put a stop. Go down.
High detected.
reset high detector. Reset it. Okay, now the pump. That's the pump. Go up, pump. Okay, if I want to off this, I need to cut off this, right? At the same time, I need to off this memory also. Because this memory I set here. Okay, go down.
So same thing lah.
Same thing lah. So this one no need pump off, no need actually. So
Don't have to reset.
no need because you didn't set the pump, right?
Yeah.
It's a normal coil only, you know here.
Pump off.
Normal coil only, so no need to reset. So reset the mixer.
One moment ah. So mixer off is set. Okay, set.
No.
Just now we done already mah.
We done already for mixer, now we're doing for pump.
So the
For the pump, you need to put stop here first.
Okay.
Because that stop is to cut off the latch.
Alright.
Okay. Then this memory also I need to reset because I set here. Because if I only stop here, it won't work because
Yeah,
since
because
it's
it has to
set.
So the mixer off, I must reset.
Reset.
Okay. Which is this one.
Yes. Okay. Here reset.
Alright.
Okay, you go up a bit. Okay, you see if you see this one high detector LL cut off and the mixer off, right? Okay. So these three and these three is not the same one.
Yeah.
So if these three and these three same, the stop button you can add below here. But since it's not same, that's okay. But I think the LL cut off also need to reset, you know.
Oh yeah.
Where is the LL cut off?
Low level.
Go up. So I also need to reset.
Okay.
Because if no, when I press stop, it is cut off, but this one is still be on.
Okay.
So add one more line here. That's how we do the program.
I learned another thing, like work backwards if there's a problem.
Yeah, of course, that's how we work. Another thing, when you do a project, like this is a flow, right?
Yeah.
So don't think of how the machine works. Because you add this. Actually, it's memory or only, if you ask me. This memory or this steps or only because you just play with the low level, high level, your sequence will be correct.
Can you give me the answer to this?
Okay.
Then after that, I just compare. Yeah. Let's just run this
You
first.
just like this first, and after the break, we can find it out. Proper one. Not a proper one, there's another way, another version.
Okay. So, okay. Okay, this is okay. So the stop didn't stop it, right?
No. You stop first, you press the stop first.
Press already.
You press ready, go up. Okay, why valve B set not reset? Go down all the way down. Because your low level is on, is it not?
Correct. No level is on.
So where is the problem? Go up. Go up. Go up. Okay, you remove the stop.
Remove the stop. I didn't press it.
No, you didn't press it.
I press already and I let go.
Okay, you press again. Okay, because you cut off this, right?
Yep.
So since the low level is on, it on back this. Okay? Okay, we solve the issue now. So now the problem is this one because when you stop, you reset this, right? When you reset this, it will become normally close again, right?
Yep.
So it will timer run. But the low level, because when you press stop, when the water is going in, right? You press stop, you suddenly cannot go and off the low level. If the water level is there, the low level will be still there, right? So I put the interlock. This is where I put the interlocking. When the low level can on, according to this, right?
Okay.
When the low level will on.
When will it on?
Yeah.
After the low level sensor.
Yeah, that's right. When the level sensor will detect when there is a chemical in, when there is a water in, right?
Yeah.
So how I know the water in or not? From the valve A.
Okay.
Correct. So when the valve A is on, then only the water start to fill in. Then only it will go up until the low level. Correct. So I can put the valve A as an interlock here. So when the valve A is running and low level is on, then only the timer will start. So when you stop, you will off the valve A, right?
Yeah.
So if the valve A is off here, so the timer won't run.
Oh, makes sense. Very logical.
Yeah, that's the thing.
Very logical.
Because this valve A interlock put it here, right?
Yeah.
Actually, when you want to write down, you won't get that idea. Actually, I know it because sometimes I do this project for other participants also. Here must put the valve A.
Yeah.
But why I didn't add here as an interlock? Because you need to think. Because when we start, you design a machine. Okay? When you design a machine, you will write down your own flow, correct? So when you write your own flow, you don't know what are the interlocks you're going to add, how the machine going to work. No.
Yeah.
Okay. So when you do testing, then only you know. Okay, the low level, if it is always on, if I stop already, it's on off, right?
Yeah.
Timer start again. So how to solve this issue? Then only we will think. Okay, when the low level can on, when the valve A is running, then only can on. So I put the valve A as an interlock.
Makes sense.
So that's how you do normally.
Going for a break soon?
Yeah. Okay, good.
Yeah.
Okay. You already received your food, right?
Yeah, it's here already.
When you go, you have your lunch first. Then after that we discuss. We see what we can modify here.
I just want this thing to be. I feel like I'm creating solutions for further down the road, but I should follow this logic to simplify the.
Yes, because that's what I said.
Like after you explain to me, yeah, it's really very logical.
Yeah, that's what I said.
Yeah.
You need to create a flow using the flow chart first. Because the one you're doing, right? You know what is this? Actually, it's like the final draft. Because you think, okay, this is how the machine not working, then only we do this type of modifications.
Okay.
You're supposed to follow this first.
Only use the input and output.
What not necessarily. You can create memories. That is up to you. No problem.
Okay.
But what I mean is, you follow this sequence first. Create the program first. After that, then we see what are the problems we face when suddenly if I cannot stop, on, off, everything. Then when you download to the machine, when the machine is working, then you see, okay, high level is on, okay, when I stop not running, okay, then only you can.
Okay.
Okay, man. Go for your makan first.
Going back for lunch?
No, I'm not here. Good. Okay.
Yeah.
So this is your version, right?
Yeah.
We do another version.
Okay.
What do you do? We go to project, save as,
New or serious?
just save as. So you can use back the IO. You put version 2. Day 2 mixer V2. Oh, you already have V2.
Yeah, I was trying to redo just now.
Oh, okay.
Okay.
Then go back V3.
Okay.
No, just add V3. Save. Okay. Yes.
Okay.
Then you delete your program. I mean, the first line you delete. You delete the program.
You know the function.
Right, just click the network.
Uh-huh.
Control A, then you delete all. Okay, right click, insert network.
Alright.
No,
Okay.
right, insert. Okay. We follow this up.
Okay.
Then we test. Any problem, then we change. You see how I do. Of course, start. Then valve A on.
Is there any way to reorder this one?
No, you need to erase all that.
Walao. Just now I accidentally deleted one and added it back.
Yeah.
Okay, no problem. Okay, start.
Then then output.
So this one will
Yeah, the valve A.
be
EA, then you latch it. Start valve A on, done. Okay. So when low level on, timer. Okay. The second line, you put a low level. Yeah.
okay.
Only open low level timer.
This one will be low level. Then a timer.
Yeah. Use back the same timer. LLM. Yeah, okay. Then put 5 seconds. Then create a memory. Output M0. LL, okay, use the same name lah. So
Okay.
start valve A on, done. Valve A dot done. Then low level timer done. This one off the valve A. Okay, go to the valve A.
Go to the lobby.
Valve A output. Yeah.
Okay.
Okay. You add a normally close in front. Yeah. Normally close.
Normally close. I can just click normally close.
Yeah. Okay. The memory.
Alright. So
And 0.0.
0.
Yeah, 0.0. This memory just now.
Okay.
This memory put it here, right? You see, very, very simple. Start, valve A on, done.
Yes.
Low level, timer. Okay? then the timer will have a output. Okay?
Okay.
Then that is this memory, right? Timer V8.Q is my memory. Then I use the memory to off the valve B. Okay? Now I use the same memory to on valve B. You put it here. Use the same memory M0.0. Then output valve B. Okay, good. What do you do? You stop until here. You test this now.
Okay.
Okay. You download and test. Did you do that way or you finish everything then only test?
I did until I think the mixer, just before the mixer.
Okay. Because why I want to download and test? Because I want to know. Last one, right? Just now we do that. This one I want to know whether I want to latch or not. So I just want to test it out.
Okay.
So that's how I do. Okay, monitor. Start. Okay, low level 1. Okay, so the what means this memory is continuous learning, so you need to latch it.
Okay.
Correct?
Because
No.
the
We don't see that. We just see that.
Okay.
This one continuous learning, so I don't need to latch it.
Okay.
Okay, that's all. We don't see why this one is always on. No, that's not the problem now. Okay, I just want to see whether I want to latch it or not. Okay, go offline. Okay, so valve B on ready. So now high level of the valve B. Okay, where is the valve B? Here. So high level want to off means normally close high level. So, and high level on valve B. Same high level on the mixer. High level on the mixer. Okay. So this one consider no need to latch also lah, right? Because this is always on, right?
Yeah.
Okay. Then same high level on the timer. So you click here, add a branch, put normally open high level, add a timer. You can use a timer here.
Just drag and drop.
No, this one you click here.
Alright.
This timer here, right? Let's click. Okay, choose the just now timer mixer. Got it?
There's a new one, I think.
No, you don't have this mixer timer.
Oh.
You delete the name timer. Okay, now you drag.
Oh, okay. Okay.
Okay, never. We just put timer mixer. Okay. Alright, put 5 seconds. Okay, so you see your high level of the valve B. So high level of the valve B. Same high level on the mixer. High level on the mixer. Same high level on the timer. High level on the timer. Okay. Then the timer will have an output. Okay. Add an output for the timer. One memory. M0.1. Enter. You rename it.
How to rename it?
Right click rename. Mixer off. Okay. So until here enough. Okay. So done. Okay. Until here done ready. Then okay, we do until the mixer off first. Okay.
Yeah.
Then When the timer is done, mixer off, right?
Mm.
Okay, put it here, normally close.
Cannot drag, right?
Cannot drag, because if I drag it move. Can copy paste. No. Yours is 0.1.
Eh?
Because this one is from the previous project. M 0.1. Okay. Yeah. Until here stop. Test. You off the switch, all the switches and test. So until here. Monitor. Go up.
Okay.
Start. Okay. Low level on. Go up first. Let's see. Okay, now valve B on already, yeah? Valve A off already, yeah?
Okay.
Okay, valve A off, valve B on, go down. Okay, now on high level. Okay, valve B off already. Mixer is right. Mixer on. Timer running. After timer, mixer off already. Okay? Okay, you off the sensors. You see, yeah? These two, the front one is the same thing, right? Actually, I can simplify this. Okay.
Just drag the.
Yeah, you click here, you add one branch. Okay. You highlight the whole thing. From here, yeah. Just drag and hold here. Yes. So this one not needed. No, you must delete this. Delete. Okay. Now, the mix, the timer, this one right on the pump.
Yeah.
Okay, you put it here. Okay, then pump, output pump. Then when high level, low level off, timer run. Okay. Inside here, itself here. So consider off means when it's normally closed, right?
Yeah.
Put normally close, normally close, normally close, to normally close. Okay. So high level, low level. Okay. Then add a timer.
Timer.
Pump.
Which one do you want?
Timer pump.
Timer.
Okay. Then put 5 seconds. Okay. Then create a memory. Because you see this one timer. Okay. Then the memory M0.2. Right click, rename, pump off. Okay, then the memory must off the pump. So where is the pump? Here.
Okay.
Okay, put it there. Memory close, pump off. Okay. So according to this flowchart, I've already done the program. Okay? I just follow this flowchart. I didn't add anything extra. Correct?
Okay.
Now I test. Okay, go on my HMI download and test. At the same time, what we do once download done, you open a wash table. You go to wash table, add new wash table, you add all the outputs, valve A, then you click here, drag,
Oh, okay.
close forwarding. Monitor,
Sorry, wait.
Okay.
Ah.
Okay, make it floating window. Bring to the side. Okay. Go up here. Up. Yes. Start. Okay. Valve A on. So I can see here is okay. Low level on. Okay. Valve B is running. Okay. High level on. Okay. Valve B off ready. Mixer running. Mixer off. Go down. After 5 seconds, pump is on. Okay. Now, pump on ready, right?
Yeah.
Okay. Now, high level off. Okay. See, there's two things. When high level off, your pump off ready.
Okay.
Correct.
High level. Okay. So
No.
high level.
Don't see that.
Okay.
See your program. When
Yeah.
high level off, your pump off ready.
Yeah. Correct.
You see here. Okay. Why? Because initially, how the pump on? By this memory, right?
Correct.
This memory on the pump. So when you off the high level, this memory off ready.
Okay.
Correct. Because this memory is from here. This one from the timer. This timer is from the high level. Okay. So there's a no problem here because I can latch it.
Okay.
Okay. I can latch it. So you latch this first. Yes. So this one is not in your flowchart. When we test, then only we find out this problem. Okay. Now we open pump, we latch.
We need to put it.
Latch it. No. Okay. Yeah, because this one need to cut off the pump.
Correct.
Okay. Put the pump here. Okay. Good. Okay. Download. Then you off the switches. Just again. Okay. Go up. Okay, just again start. Okay, one here, okay, low level. Okay, one B, okay. Then high level. Okay, go down. Okay. Now pump on. Okay, high level off. Okay, see pump stage here off. On.
Yeah.
Okay. But you see, valve B on back already.
Oh.
Okay. Correct.
Oh yeah. I would never have seen the. Yeah.
Can see here, right?
Yeah.
Okay. Okay, never mind. Okay, when low level off. Okay. I run for timer, but your valve B off already. Okay, never mind. Run for timer, pump off already. So this problem is solved. But now we see why the valve B again on, right? Okay, you go up again, you try. We try again. Start. Okay, low level on. Okay, go down. Valve B on. So we just see the valve B. What
Yeah.
happened to the valve B?
So how is so we just stay here lah.
Yeah, stay there. Okay. So this one cut off already. This one is still on.
So you have to pay
Okay.
attention to the pump turn on.
Yeah, pump
Okay.
turn
So
on.
now I turn off the high level.
On back.
Yeah.
Because when I off the high level, I on back. Okay, why? Because of this memory. This memory is from where? From here.
Yeah.
This memory is from the timer. Okay, it means it's supposed to off, right?
Yeah.
But it's still on. Why? Because of the low level is always on. So I cannot cut off the low level because the pump is still running.
Yeah.
Now only, so according to your project, right? Your pump is on, at the same time your valve B, so it's still filling.
Yeah. So you will never get to the low level.
Yeah, never get to the low level. So of course this one won't off. But can I off this memory or not? Of course can.
Okay.
Correct. Okay. How to off this memory? By cut off here or here. So the best one is cut off here. Correct.
Yes, makes sense.
Okay. So what I can use to cut off here? There's many things. Don't think of this. That's what I say. Now, you see, now, what is running? Your pump is
Now
running.
the pump is running.
You can put the pump as an interlock.
Oh. Okay.
Okay? Put the pump as an interlock. Okay. Now you try again. You off all, then you try again. So you get me right how I do the program one by one. I do the program, I test one by one, and I solve the issues. Okay.
But how do you know when to put two things in one network or one
What I
thing in one
do
network?
very simple. You go up. This one for valve A. Right. This one for valve B.
Okay.
This one for mixer. Just manage the outputs. According to the outputs, like easier.
Yeah, it's easier.
Yeah. Okay. So if anything problem to valve A, I go to the network one easier. Okay. Same like just now also you do like this, right? I think so.
No. Network 1 is the top only.
Oh. Okay.
Then the second one then is the timer.
Oh. Okay. Okay. Now you test. We see the problem. Okay. No level on. Okay. We just concentrate here. The valve B only.
Okay.
So of course it's still running. Okay.
Yeah.
That one I don't care. This one is still running, don't care. But the moment high level off, I don't want this one on. Okay. Okay, now you see off already. Correct?
Yep.
Because your pump cut off already. Okay. Now high level off. Okay, no problem. Okay. So only the pump is on. Okay. Now low level off. Yes.
Yeah, nothing turns back.
So when low level off, of course it won't boom back. Yeah, after the timer, the pump will off. Done. Okay?
Yep.
But we haven't done yet.
The stop.
No, stop later.
Okay.
Okay. Now we already done everything. All good. Now we test our program. Okay. Let's say I haven't pressed the start button. Suddenly the low level is on. Okay. You on the low level, switch. Whatever.
Timer.
Timer, right?
Yeah.
Memory on, suddenly VB on.
Yeah.
So this one shouldn't happen, right?
Yeah, because nothing is inside now.
Now nothing is inside, right?
Yeah.
So suddenly low level, let's say the sensor is faulty. Suddenly give you the signal, on signal.
Yeah.
Then suddenly the valve A can on. So how to solve the issue? So when the low level, same like just now in your program we had, when the low level can on, when the valve A is running,
When the valve is running. Yeah.
then only you can detect the low level, right?
Makes sense. Yeah.
So I put a valve A in front. Same like just now in your program we had.
Yeah.
Go up. Yeah, here. Okay, so
Only when this is running.
so when this one running, when low level is on, then only the timer can start.
Yeah.
But now in this case, low level on, valve A on low level. After the timer, valve A will off.
Alright.
So this memory also will off.
Okay.
So now the valve B cannot on already. You know why? You see, I start valve A on, here I on, right? The moment low level on, timer run, after the timer, valve A off. So it will cut off here, this one will off. When this one off, this memory also will off.
Oh.
Cannot.
Cannot.
Download test.
Cannot. Okay.
You off, you download test.
Alright. So we just do you have to restart anything?
No, download first.
Oh yeah.
Because we add something.
Okay.
Okay, start low level on. Okay. Valve A already, but valve B not on. Correct. Why? Because the moment what? This memory energized, right?
Yes.
You cut off the VA.
Right.
So when VA off, the timer will reset.
Oh.
Correct.
Okay.
So
Right.
now this memory is become like on off.
Yeah.
Earlier when this one don't have, it continuously on, right?
Yeah.
When I add this one, this memory become on off.
Yeah.
So I need to latch the VA.
Okay. You need to latch this.
Yes.
Okay.
Yeah. Add here.
You need this. So that, okay.
Okay. Again start. Start. Okay, working on low level. So now actually this one don't need to be. Because this memory, right, is not continuously on one. Earlier this one is continuously on, that's why we put this interlock.
Really?
Yeah.
Okay.
But now I can leave it, no problem. Okay. Valve be on. Okay, now you just one cycle. Can go
Okay,
right?
okay.
All okay. High level.
This one should turn on.
High level.
Yeah. Turn the wrong one.
Okay.
Okay.
It's running.
Okay.
Okay. Go up. All okay, yeah. So now you on low level. Only nothing will happen.
Yeah.
Okay. Off. Okay. Now go down. You on the high level. Okay, what happened?
Restart.
Mixer running.
Yeah.
Okay. Now we try to solve the issue.
Okay,
Why?
so the high level can only run when valve A and B are on.
Not valve A and B. Valve B, because valve A will off first one.
Yeah.
Then only the valve B is
Yeah,
on.
because they want protected already, they want interlock already.
Yeah.
So now we left valve B haven't interlock.
Yes, valve B.
Okay.
Okay. So
So we put a valve B in front of the high level detector.
okay, yeah, try. Okay, now you start. Okay, whatever.
Right.
Not running, right? Why? Stay. Why? Go up. Let's go. 3, 2, and 3. Okay, this two. Okay. So you see here is the LL off, right? The memory.
Low level off.
VB. Left the VB. High level. Okay.
Yeah.
Then you put the VB as the interlock. Then when high level on the mixer, right?
Yeah.
Correct. Then there's a timer. Mixer off. Then you off mixer. Okay. So just now we don't have this, right?
Yeah.
It's working. But when I add this, the mixer can run already. Okay, why? Because see, after this memory on, VB on. So normally closer, right?
Yeah.
Your current will go like this.
Right.
Then VB is on, right?
Right.
Then the moment you on the high level, here also on.
Oh.
Okay. So what happened? You cut off your VB. So VB off already.
Yeah.
So can I give the signal?
Yeah.
Correct.
Correct.
Okay. So what I do? So first I need to latch first. Latch the mixer. Because biologically, if the high level on, of course the VB will off.
When the high level is on,
Of course the VB will off.
okay, correct.
So it only can give like one signal only.
Okay.
So I latch it first. Here you can learn one more thing. Now, after the before valve B, can also. Here also can, here also can. I will show you.
Okay.
Okay, now you test. Test.
So this one will latch this.
Yeah. So whatever, the VB on, still on that running right.
Correct.
High level on, I can give you one signal, you can latch it.
All B on. Okay, so all B on.
One be on, high level on, then mixer can on.
Correct.
Can right?
Correct.
Okay. Download the test first. Whatever. Okay, wait. You see properly whatever. Click it.
How many?
No, click it.
Click here.
No, click it. Empty space. Okay. So you see, when valve be on, okay, now it's ready for the high level, correct?
Alright.
If the high level on, the mixer can on, I can latch it.
Yes.
Right? You understand that part? You are not clear, you let me know.
Because now the now
No, don't see that.
Yeah, okay.
You see here, now here is on already, right? If this one on, the mixer can on, right?
Yes.
If the mixer on, I can latch it, right or not?
Correct.
If we logic, it can work.
Yeah.
Okay. You on the high level. Okay, you see it's on already, right?
Oh yeah.
Why mixer cannot on?
Valve B on valve B
Off already.
off already.
Okay, you see why? Because this is where, but if we see the logic, you see, if you see the logic, okay, valve B is on, high level on, mixer should on.
Yeah.
Okay. But here, the scanning is the play the part here. Okay, you see how it goes. The moment from here, low level off already,
Yeah.
valve B on, right?
Level off from here, yeah.
And valve B is on. It's
Yeah.
ready. Okay? Ready? So you put the latch here. Okay, no problem. Okay, so then when you on the high level, my PLC will scan this first. Correct or not?
Yes.
Then only PLC go to here.
Correct.
So when my PLC scan this, it says okay, turn off ready. I mean on ready. Correct.
Yeah.
I cut off this.
Mm.
I cut off this. I off this. Then when this one off, here also off.
Ah.
Then my PLC go here to try to run cannot ready. Because before my PLC go and scan here, VB off ready.
Okay.
Okay?
Yeah.
Okay. How to solve this issue? But I want to use the VB as an interlock because when the valve B is on, then only I can reach up to high level.
Is this when we use the set and reset?
Not necessarily. Not necessarily. Just
Okay.
think of the logic. Okay. The idea is valve B must be an interlock for the high level. Not must be, can be an interlock for the high level. But when I use the high level here and here, there is a clashing. Correct?
Okay.
So means this one is network what? Network 2, right? This one network 3. Correct?
Yeah.
If I bring this network up and bring this network down, it can work.
Okay.
Correct or not?
Makes sense.
Okay? But if you want to write in the flow, that is not a good practice. So what I do, I know I want to off the VB when the high level on. Right on. When the high level on, I want to off the VB, correct?
Right.
At the same time, when high level on, mixer also on, correct?
Right.
So what I can do, instead of high level of the VB, I use the mixer to off the VB. So what happens is, when after this one, VB is on, I latch it. So when VB is energized, when high level on, high level will on the mixer first. Latch it first.
Okay.
Then here we cut off. Correct?
Yep.
Then my PLC go down and then go up and scan, then only we off the VB.
Okay. Wow, this is a lot of checking on.
Yeah.
Bro, second day only.
Yeah. No. This one, never mind. Okay. The thing is, you doing this project is not important.
Yeah.
Okay. I say, okay, I tell you, give this one. I ask you to finish it. Just now you already do. It's already good enough already.
Yeah.
This one, because why? This one we can learn so many things, because from just now from the high level here and here, we know that the arrangement of program is very important.
Yeah.
The second network and third network is just a network only, but we know how the PLC works. PLC will scan this program first, then only we scan this program.
Okay.
Then that one thing we learn here. Another thing we learn here is supposed to be an input that is cut off here, right? But I can use the output to cut off also. Correct?
Okay.
I don't need a memory to create here. So there are two things we can learn here. That's the important thing.
So you must actually really test it.
Yeah, of course. That's why you see. You see how I do. I test. I test.
Yeah. Wow.
Later got some more.
Okay.
For the we haven't do the stop first.
Yeah.
Stop yet. So later we face some issue also. Then we can solve the issues.
Yep.
Okay. So you change this. So mixer. Then your problem solved. So not necessarily, this is where sometimes people don't get idea, they use memory. Just now, why you use memory, it's okay, it's correct, nothing wrong. But you didn't get some ideas like this, correct now?
Yeah.
But you see, it's on, okay, but how to stop, okay. The very simple thing for the valve A, okay, sorry, the low level timer, we put the memory set, right?
Yeah.
The what? For this
I set the task complete. Yeah.
task complete, right? Okay, so actually, according to this, I don't need really. It still can work also. But what I do, instead of you go up, because earlier I saw you use a set here, then you use this one to cut off this one, right? But since I'm adding this pump and the valve A, I don't need to set this one already. Because earlier you didn't get this idea, right?
Yeah.
So you use the memory to set to cut off. Can work also. Because just now your program also can work, right?
Yeah.
So there's nothing wrong. Because slowly you need this one. Okay. Then another one more thing is, this is logic.
Yeah.
Logic is, of course, you do play around, then only you can test different logics, So your mind always will have a different way of solving the issue, different way. The most important for me, what is important, you need to know how to use the timer. You need to know when to use the memory. You need to know when to use set reset, when to use the pulse. Even I can use one of the input output, right? I mean one of the output, I can use a set reset also. Okay. That's the most important thing. That's what I will see whenever you do a project. that is what I will see. Because okay, I teach you how to use timer, then I see how you use timer. Correct or not? Okay, correct. That's all. Your logic wrong, it doesn't matter. It's secondary. Because now only day 2 ma.
Yeah.
Okay.
Okay, so I added the mixer.
Yeah, mixer. Okay, now you test. You see can work or not? Okay, now you cannot imagine. Over the time when you do, keep on doing, sometimes you can imagine really without testing. Correct or not?
Yeah.
Put up. Now then you see mixer can on. Put up.
Mixer
Off already. Off the time. Yeah. Okay, put down. Yeah. Then off. Okay. Now we add the stop button.
Okay.
Sorry, high level, low level off. Okay, anything on? No, right?
Wait for this one to finish.
Yeah,
first.
okay, nothing on back, huh?
Yeah.
So good, okay, completed. So we test this program all okay. Then we test with the low level and the high level interlocks. We tested all okay. Now we do the stop button.
Okay.
Go up. Okay, for this stop is very easy lah. You put the stop here, you can cut off already. You put the stop here. So for 1B also same, right?
Yeah.
Just copy paste. Go down. For mixer also, right? Right.
Mixer.
Because
relying on this.
relying on this one, right? When the mixer is on, relying on this line only.
Right.
So I just can put it here.
Whether in front or not, it doesn't matter.
Doesn't matter. Okay, the pump also, yeah. Okay, that's what we.
Interesting.
So now you have another perspective how to see the program. Stop. Okay, good. Okay. Now you start. You check with the low level. Low level. When valve B on, then you press stop. You see, you can go on. Low level. When valve B on, you check the stop. Can go.
Yeah.
Okay. You off the low level. Again, you start. Now wait for the mixer. Okay, low level on. Okay, now wait for the mixer. When the mixer on, you press stop and see. Can go on.
Okay.
So that's how we do.
Go to high level.
Mixer on already,
Yeah,
stop
already.
Can off.
Yeah.
Okay. Same go for the your pump also.
So if you press start now, it will continue.
Okay, good question. That's okay, good question. Okay, will continue, right?
Yeah.
But you see again, valve A is on already, right?
Now,
Okay, now you start.
Got on eh?
Yeah, you start.
Yeah, it's at the mixer stage already. It's at the pump stage already.
Pump station already, right? Now you press that. Valve A on back.
Maybe.
Okay, that one later we solve the issue. Okay, now the pump is on, right?
Yeah.
Okay, you press stop. Pump can off.
Can.
Okay. Now you go up. Okay, now for the valve A, when low level is on, right? Valve A is supposed not to on, right? Because
Yeah.
the level is here already. Means
Yeah,
something
so I
wrong.
fixed it just now.
So how? So the condition is, before I press start, I make sure the low level and the high level is off.
this one in front we put 2.
2, the low level and high level off.
Okay.
Stop. Okay. You run, stop. Can go. Because aku dah interlock already.
Yeah.
Okay, now. That means, of course lah, this program is not according to this whatever we discussed, the flow is okay lah, correct. But if it is actual system, then we need to add manual discharge, manual drain, all that we need to have. Okay? Because now the level is there already, right?
Yeah.
Low level, high level. So how do you going to drain up? Correct?
Yeah.
Okay, that was it's another additional inputs lah.
Okay.
You don't need to think about that. Okay. Now, you see, we minimize this. Initially, when we follow this, right, this program is very simple, correct?
Yeah.
Because this one don't have, 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 right? And this one don't have, this latching don't have, go down. This interlock don't have, this latching also don't have, then this latching also don't have.
Yeah.
Okay, so when we follow this, we can only take a look at this. Then when we do testing, then only we face one by one issues. Then we solve one by one issues. Okay?
Yeah. Good. For now it's okay.
For now it's okay.
Yeah. A lot of things to take in.
Okay, that one is okay lah.
Yeah.
But you get the idea, right?
Yeah.
How I do the
Yeah.
program. One by one, slowly,
Yeah.
one by one. Test it out. Sometimes you cannot imagine, test it out. Why not working?
So many things.
Yeah, of course. Logic.
That is the Bahru.
Yeah.
So how long do you take to, just now you show me the 20 plus that one.
What? Both days are many days.
Also you just keep testing lah, but
Yeah, of course. I test, because they give me one flow, I do. Then, send them, then when tester got some issue, then I troubleshoot, update. I think that number of days I work for that, if I calculate this, I will tell you like 6-7 days.
one day did that wash table.
Easier to see, right?
Yeah.
Okay.
I think I'm going to study the. You told me that if actually this PLC came up because of the analog relays, right? How did they do it before memory? There must be a way, right?
Actually, that's a relay. Your memory is actually a relay.
Oh, I never thought about it that way. Oh.
Yeah. Actually, the memory, some PLC, right? It's your memory. The M, right?
Yeah.
Okay. In this case, we have a timer, so as an output. So for the output, we need to give a name, right?
Yeah.
Means because there's an output. Very simple. The idea is after timer there will be an output. Means the value become 1. So where I want to store the value 1. So I take the memory, I store the value 1 into the memory.
Yeah.
So later on I can use the value 1 wherever I want to use.
Correct.
That is the concept.
Yeah.
Okay. But actually if you take a timer relay, under the timer relay, we have an input and an output coil.
Yeah.
So the coil is the memory under the timer relay. Let me check I got memory or
I'm getting it. Yes.
So some PLC, right, like Mitsubishi, if you go to the manual, for the memory, right, they got auxiliary relay. It's actually a relay. That's why they have a coil and contact.
Interesting.
This is a timer. Okay, you see, it's a timer on. So,
The screw.
So you see, got contacts. You see, open, close, open, close contact.
Yeah.
So the open, close contact actually is the memory, the output.
Yeah.
So, but here don't have like output lah. So I straight away use as a where I want to use to on a VB. So there is an input. Input is to power on this. Okay. So let's say AC or DC lah to power on negative, positive. I power on this. I know we start to come. After the time, I use a normally open contact. Let's say 3 and 2, right?
Yeah.
So I open contact to on the VB. So from here I go to another relay on the VB. That relay will energize the valve. This one also same. You see?
This is also a timer.
A timer, the same one. This one you can choose timer on delay, timer off delay, everything under the B. And how many seconds you want, you can choose also here.
Also, this one can be a T on and T off.
Yes, you can choose here A, B, C. Then the percentage will choose for the timer, everything. So you see to on this, there's a and B.
Yeah.
And just here also got. Okay, but this one what can you see is a here we have a NC and O. NC and O.
Normally close.
Normally open, normally close contact. So this is
two
the
is a pair.
so this one is the output lah.
Okay.
Their output lah. So once you reach, normally open become normally close lah. So where I want to on what? Okay, I take from here and on that. So this is considered memory. The output is considered this here is the memory.
Okay.
The relay is the same. You know, right, why we use memory? Okay, another question. Why we use memory actually? If I don't want to use memory, can I use other things or not? Can. I can put course lah, I cannot because I is the input.
Yeah.
Input always must use normally open or normally closed. Okay. So and out here I can use a Q also 0.5. Okay, so right.
What do you mean?
I can use an output also here, correct?
It can be lah, but
Can.
yeah.
Okay. I can use the output here. Then the same output I use here to off. Correct?
Okay, correct.
If I follow the logic,
Yeah.
can work.
Can.
But I'm wasting one output.
Yeah.
Right?
Yeah.
Because why I need a coil here? Because I want to take the signal that I get from the timer, then I want to use somewhere else. So instead of using the output, physical output, I use a memory. Because for memory, there's no output. It can be inside the program.
Yeah.
That is the.
I have problem remembering all this, like how many memory I got, and then yeah, I have a problem.
Oh, how many memory you have?
Yeah, maybe I should open the table and then I just look, right.
Okay, there's so many memories actually. But
So like I already like 0.00.1, 0.2, and just not 0.3,
you can go until 0.7.
and then after that you jump to 1.
1.0, yes.
Okay.
Okay, good.
Yep. Yep.
Okay. Now what I want you to do is this is a okay. You save this project. Just save as. But I don't want to renew project. Choose again. I don't want.
Before.
No, not before. Day 2, lesson 1.
Day 2.
Or you put day 2, HMI 1.
Okay. HMI
1. Yes. Then you delete all the programs. And you go to the tag table, you delete everything, just keep start stop, one output motor enough. Can I use this?
Wait, let me check whether I took a picture of that. Okay. I mean the flow is already in my head already. I mean whether it's still there next week or not, I'm not sure.
Not an issue.
Yeah. Okay, thank you.
Because I cannot expect to, okay, I teach you, okay, then immediately you know. What I see is, okay, I teach you how to use the timer. I see how you use that, the way you use timer correct or not. The way you use memory is correct or not. The way you put normally, that's all. Logic is, you need, of course, need time to, play around, do projects. Even if still you ask me to do some logic, of course I also need time.
You say your all the text delete except for
start stop and one output you keep motor. Everything you off. No, wait. You click on the number 3, then I highlight. No, again you click the last one first. Okay, again you click and drag. Yes. Delete. Put one motor. So then you get a simple program like this. Then your DB also you need under the program resources. This one another thing important. Because I want to do a simple thing in the HMI.
The top, the first network, right? Before the motor output, that one is
M0.0.
okay.
Then this memory, this memory I use here. Then simple start stop motor.
Yeah, all that.
Okay. Rename the memory Moto 1. Sorry, Moto 1 off. Now, want to do a HMI, right? When you want to do a HMI, how the HMI work? HMI work is very simple. HMI just read and write the data only. Read and write the values. It's not. There's no programming in the HMI, right? Take a button, you put the address. Okay. So we can for the addressing, right? Start, stop, motor addressing. You can use DB. Okay. You can use DB or you can use memory as well. Okay, but I want to show first using memory first.
Okay.
Then we use the DB lah. Okay, start. So means why? Okay, very simple. When I press the start button here, the motor need to on. It means this address is what I0.0, right?
Yes.
Okay, this is 0.1. I cannot use the same address here. Why? First thing is I is physical address.
Okay.
You remember before yesterday before we do the wiring, right?
Yeah.
You cannot turn on.
Yeah, you need to force it, right?
I need to force it,
Yeah.
right? Okay. Fine.
No, thank. Just a little bit outside, so just in case.
No, the tissue there so.
Okay. Alright.
Okay. So I cannot use this address. Okay. For the button, why? Because the function of the button is to write value. Because to send the value to here. Okay. The function of the lamp, this is the lamp. The function of the lamp or changing color something is read. Means I read the data from here and change color here.
Yeah.
So for moto, I can use back the same address, no issue. Okay, but for the button, I can use the same address. So I must use a memory. Okay, so what memory I can use? M0.0 already used. So I can start with M1, 0.1, 0.2, or I can start with M1.0, or even I want to start with M10.0. It's up to you.
Yeah.
So, but I just follow this line. So already used M0.0, 1, M0.2. Okay. So what I do? Now I have a new memory, right? So I need to add this into my program as well. So I want to add below here also can or below here also. The better one is below here lah. Okay. M0.1. So here this one is the motor lah. So I name it as a HMI start. So now I press this start, the motor get on. I press this start, also motor get on.
Oh yeah.
Right.
Okay.
That is the function lah.
Yeah.
That's how it works. Okay.
Yeah.
If I only have in the HMI only, then I don't need this one. This one just replace here.
Okay.
Okay.
Yeah.
So now I have both place lah, push button and also the HMI.
Okay.
Now I for the stop button here. When I press this stop button, the motor need to off. When I press this button, motor need to off. So here. HMI stop. Okay, good.
Yeah. So whichever one also can.
Cannot. Okay. So the output is okay. But let's say I want to put a lamp for my start button. This button, right? If I'm using a lamp, I can use the same address, no problem. For the I, because sometimes people think, oh, cannot use I, only can use M. No, not like that. The I cannot use for the button only, because the function of the button is to write value.
Yeah.
Means send the value to the PLC.
Makes sense.
So if I add the address I here, because this is a physical input. But for the lamp is to read. So I can do. Okay? You add these two first. You test first. Then we go for the timer input and display. This one. That is very interesting. Okay, good. Okay, download and test. Okay. Right. Your memory is on M0.2. Maybe from the previous program.
How about we stop it first?
Stop better.
That's not also have this problem. I just restart and can.
Yeah, because memory, the value is already you set that, right?
Yeah.
So the new project, the memory is still there, right? Then it will affect the program. So stop it. Now start. Okay, go right, stop. Okay. You right click this start button, modify to 1. Yeah. Right click this memory, modify to 1. Okay.
Okay.
Okay. Modify to 0. Okay. And go right?
Yeah.
Okay. Good. And we save it.
So it works.
Okay. So means you can use memory or DB also. First I teach you memory, the next class I teach you the DB. Okay? Now for the timer, right? So now it's a 10 second, it's a constant number, means it's a fixed number. So if I want to key in the HMI, I need something to store the value. So I can use a memory or DB. So first we learn the memory first. Okay? So what memory I can use here?
What memory?
Yes. What address I can use here? Here I use M0.0, right?
Yep.
Why M0.0?
Why M0.0?
Why M0.0? Why not is MW? Why not is MD? Why not is MD?
Because every time we only store the binary number.
Yes.
Yeah.
Binary is actually Boolean.
Boolean, yeah.
Correct word is a Boolean because the coil is Boolean.
Yeah.
Okay, so that's why we're using a M0.0. But it can be any number also lah.
Yeah.
But it must be a 0.0. Okay? Here, you bring the mouse to this line and see what is the data type here. To the line, the orange, the line. Yeah. Time, like just yesterday we saw, right?
Yeah.
Word
double integer.
and double integer. So if this one means is a 32 bit, right?
Okay.
If 32 bit, what I need to use?
32 bits.
Yes. Go to your slide. From the slide.
Hey.
Go
Okay.
down to the memory.
Which one is it?
Memory, next one.
Next one. Output
Okay.
memory. Okay.
So if a boolean I use this. If a bit or boolean, I use this.
Yeah.
If a byte means I must use a this. If a word means I must use a this.
Okay.
If a double word means it's a 32 bit, right?
Yeah.
Double word means I must use MD.
MD.
Okay, good.
Okay. Yeah.
Okay, so means that I can remove this, I can put MD, right? Okay, what number I can use?
But what's double integer?
Double word is the same
It's
thing.
the same thing.
32 bit.
Okay.
Only thing is double word in hexadecimal.
Ah.
Integer is in decimal.
Okay. Oh. So either of those. Oh yeah, they are the same size. Okay.
Same size.
Yeah, they're all same size.
Whatever number you give, it's at the end is going to be in binary only. Okay. Now, what number I can use here? MD what?
That means this is 0.0.
No, you follow that. Because the MD no 0.0, right? Only the boolean got 0.0. The points.
Yeah. So the first one will be MD 0.
0, right?
Yeah.
Okay. I tell you cannot use.
Cannot use.
Cannot use.
How come?
Why? Okay, good question. Why I cannot use? Because if I use MD0, it will clash with M0.0, M0.1, 0.1.
Oh yeah. Oh yes. Okay.
Okay, why? Because
Wow, this is an important lesson.
yeah, this one is very important. This is data type.
Yeah.
This is important. Just now we do is a logic. You can improve. This over the time you can improve. This one is like a
Foundational layer.
yes. That this is the fact. This one you need to know. This one you cannot change.
Yeah.
Okay, so because MD0 consists of 32 bit. So sum of the bit is 0.0, 0.1, 0.3. Okay, so I do an arrangement. We see how it looks. Under MD0, we have memory word 0. Under and also one by one like that. Okay. Then under MW0, we have a memory byte 0, memory byte 1. Okay. Then once I finish one, then here will be MW2. Okay. Under MW2, I have memory byte 2 and memory byte 3. Okay. So inside here,
How come it's not MW1?
1, no. And this I tell you, because under W0 got 2 byte.
Yes.
So the 1 is already used here. What?
Yeah, but memory word
Word, yes, correct.
0 and memory word 1.
No 1. This number here is represent your first byte.
Okay.
Okay? Let me arrange this first. That's very interesting. Okay. Under 1 byte, you see, under 1 byte, you have 8 bits, correct? Okay. So you see, under byte 0, I have 8 bit. So under byte 1 is an 8 bit.
Yeah.
So total 16 bit is equal to memory word. But the number is actually your first byte.
Oh. Okay.
The number is your first byte. Under here, I have already used the byte 0 and byte 1. Next number is available is byte 2.
Yeah.
So that's why it's a 2.
Okay, got it.
Okay. Here also MD0, right?
Yeah.
Under here, I already used byte 0, 1, 2, 3. So the next available is MD4.
Okay.
Got it?
Okay.
Okay. Now, that one is not important. Later we see. Now, why it will clash? Okay. When you want to key in some value, okay, you see, if I use an MD0 here, right, means I will put the MD0 here, correct?
Correct.
I can key in some value lah,
Correct.
okay? But the value will be in double integer because in the HMI it's not, it cannot have a time in the HMI. There's no time format in the HMI.
Okay.
Okay, so in the HMI either it's a decimal or hexadecimal. Okay, so for us easy to understand it's a decimal. Okay, so we use a double integer. It means if I key in 10,000 is equal to 10 seconds.
Okay.
So when I key in 10,000, what happened? Some of the bit will be 1010, right?
Yeah.
You see, so how it works, under here got 4 bytes, right? 1, 2, 3, 4. Okay?
Okay.
But according to this, for him, this is the first byte. That's why I write it down here. Because the bit will follow this way. This is bit number 0, this is bit number 31, 32 bit.
Okay.
So this is the arrangement. Okay? Because in PLC there's a two things we need to know. There's a LSB, MSB. Okay? Least significant bit, most significant bit.
Got it.
Okay? So Siemens using most significant bit.
Yeah.
So under MD0, the 3 is the first one, this one is the second, third, fourth.
Most significant bit is the right side.
Yes, not the number, higher number first, then only go to the lower number.
Oh.
Because for him got 4 bytes, right?
Okay.
This is the first bit for him.
Okay.
Means 3.0 is the first bit.
3.0 is the first bit. Okay.
Normally supposed to be 0.0 is the first bit, right?
Right.
Because since Siemens using MSB, so for MD0 the first bit is 3.0.
Oh.
Okay. For MW0 for the word,
Yeah.
for this guy the first bit is 1.0.
Okay.
That's how it works. Okay. Okay. So when you key 10,000, what happens? Some of this number will on something like this.
Correct.
Right. So this one now becomes 000, right?
Yeah.
But so what happens when you turn on this one, it become 1.
Yeah.
When this one become 1, it go and affect this number. Correct.
Correct.
So that is the reason it's clashing.
Understand.
Okay, we can test this one, then only we can understand. You go to your TI portal,
Yeah.
you go to wash table, because the wash table is the best one to understand. Open, you delete all these for. Okay, the first address you put, address. Yeah, MD0. Okay, then you put MW0, MW2. Then you put MB0 until MB3. Just pull it up. No, wait. Sorry. Your mouse, must be in this table.
Okay.
Okay. Then change all these to decimal. You change one, then you can just drag. Decimal. Okay. Then
Oh,
just-
so that's the sign and sign.
sign is the positive negative. Yeah. Then you click here, give M 0.0. Then you drag 31 row. Sorry.
Okay.
No. Never mind. Little bit also can. No problem. Later you can continue.
Oh, okay.
Okay. You continue from the last.
So we'll go until
3.7, yeah, correct, exactly correct. Okay, you make it bigger. You go all the way up. Okay, already all the way up. Monitor. You key some number here, 10,000. Enter. Modify. Here. Means I put this value into the MD0.
Oh, okay. Oh.
Okay. So you see modify variables.
Yeah.
So when you key in 10,000 into MD0, you see 2.0, 2.1, 2.2, some of this is on. Correct? Okay. You escape. Why this one is full screen? Go down.
Yeah.
No. Oh, this one is very fully screen. Okay, go to calculator. I want to use calculator. Okay, put 10,000. Okay.
Yeah.
So we see how it works. What is the numbers? Okay. So 0, 0. We see from here.
Okay.
So 0, 0, 0, 0. Then 1, 0, 0, 0. Then 1, 1, 1. 1, 1, 1, 0. Then 0, 1, 0, 0. Go and check. 2.5 is on. 2.2 is on. 2.1, 2.0 is on. 3.4 is on. Correct. So 10,000 means that this is the number.
3.4. Yeah.
Okay?
Yeah.
You go up. But you see under the MB3, what number? What is the value?
MB3.
16.
Which is.
No, 16 is because 1, 2, 4, 8, 16. If you know yesterday the binary number, I
Yes,
put the
yes.
power.
Yeah.
So this is 2 power of 0 is 1, 2 power of 1 is 2, 2 power of 2 is 4, right?
Yeah.
So will be 1, 2, 4, 8, 16, 32, 64, 1 to 8.
Okay.
So if this one on means for this guy the value is 16.
Okay.
So for this guy is how much? This one is 64, right?
Okay.
64 plus 4 is 68 plus 2 is 70, 71. Is it correct? 71?
This is MB2.
39. Why? Oh, sorry. Because it's a 32.
32.
Correct. Because 1, 2, 4, 8, 16, 32.
32.
32 plus 4 is 36. 36 plus 2 is 38. 39.
Okay.
So you see, you key in 10,000 into MD0. Your MW0 is 0.
Okay.
Because this one is 0, this one is also 0. Because all these 0, right?
Yeah.
Then MB16, so MB3 is 16 because bit number 4 is on. MB2 is 39 because bit number 5210 is on. Okay. Under MW2, you need to follow the bit number, not this plus this.
Okay.
You know?
Yeah.
So because all this on means is under MW2 is what number? 10,000 also lah.
10,000, yeah.
Yeah. Because logic lah, because this 10,000 only use this 16 million.
Yeah.
So this one is same. So what will happen is when you put MD0 here and you key in 10,000, okay, it can store the value. But the moment you press on this, what will happen? This one will on, right? When this one on, okay, the value change, right? 1, 2, okay, this one become 2. Here also the value will change.
Yeah.
When this one change, this value also change.
Yeah.
Okay, we try to on. What you do? You delete this number. Actually, yeah, you can turn on here also. Okay.
Yeah, I just press this button lah.
Yeah, I can.
No, cannot. I just force this, right?
Modify to 1. You see what number?
Ooh.
So this number, if I change to timer, it's very big number already.
Yeah.
So So it will clash. The number will clash.
Understand?
Okay?
Yeah.
Good?
Yeah.
Clear? Okay. So this one you need to know because this is how it works. Okay?
Yeah. Most significant bit is on the right side.
No, not the right side. Most significant bit means the higher number first.
Okay.
Because if I write the MB0 here, right?
Yeah.
MB0, MB1, MB2, MB3, then I put the number here means this is you will think MB0 is the first one, right?
Oh yeah, because if I use inside the system, yeah.
Because I arrange like this because the binary number always read from the right to left.
Right.
That's why I put the 3 first. 3, 2, 1, 0. Because according to Siemens always go for most significant byte. Okay, the 3 first. Then only 2, 1, 0. For MW2, 3 first, then only 2. For this one, for MW0, the 1 is first, then only the 0.
So if I were to use the MW2, then I just key in it actually doesn't matter because I can name it myself. But you know, sometimes when you just enter something, after that they'll assign you a memory, right?
Yes.
So they'll assign you the 3 first or they'll assign you the 2 first?
It will see which one is available.
Okay. Yeah.
Assigning will be follow the normal number 1, 2, 3, 4. Follow your from 0 to it will follow
Basically the table lah, just
table lah. How I write this table? It will follow this table only. When I want to assign it will follow this table. 0.0, 0.1, 0.2. Once I finish, then 1.0 that. Okay. But when I want to convert it into a binary, I need to follow this.
So when they assign to you, it's totally unused lah.
Yes, of course.
So they will know that it's unused.
Yes, correct.
Okay.
Okay?
Yeah.
Good? Okay. So now I said MD0 can use to be.
Oh, okay. Makes sense.
What number I can use?
So let me see. We are using
So we are using 0.0, 0.1, 0.2, right?
yes.
So these 3 already used.
Okay.
So here what MD I can use? Okay, the first thing I must use MD. That's what you know, right?
Yeah.
Because of double integer, right?
Yep.
What number I can use?
Probably not this one already. The next one. That means let me think. 0 and 2. Then the next one will be MD3. Is it?
No. Because you see, of course 0.0, 0.1, 0.2 already used.
Yeah.
It means MB0 is already used.
Yes.
MB1 is still available there.
Okay.
Correct.
Alright.
So I can use MB1. Okay? And
How come?
wait, you see, don't confuse. Like I said, memory you can use as a byte, bit, word, double word. Okay, it depends on which one you want to use first. So like I said, under the byte 0, I already used the 0, 1, 2 already used. Means the byte 0 totally used already.
Correct.
The next available byte is 1. Now what I want to use, whether I want to use a bit, boolean, word or double word.
Yeah.
So here I must use double word.
Okay.
And the byte 1 is available, so I use byte 1. So if I use the byte 1, here, now this guy will use MB1 plus MB2 plus MB3 plus MB4.
that's how it works.
Yes. It's not like, you don't confuse, it's not fixed, you know, zero.
Yeah.
It's no. It's based on available number, then what data type I want to use. Let's say it's only available 10, then it become an MD10.
I thought that because MD1, right? I thought it would encompass the other 16 bytes.
No.
No, not 16. Sorry. The other 8 bytes. It won't.
If I'm using MD1,
Because by right, I thought MD1 doesn't exist.
no, exists, right? Number one is exist, right?
Oh, that's byte, MB,
No. The number is always exist. It depends on you. You want to start with what? Okay? The number is always there. It means like 0, right? 0 is always there. It's up to you. You want to use as a 0.0. You want to use as a MB0. You want to use as MW0 or you want to use as a MD0.
Yeah.
The byte is always there. Same goes for 3, for example. It depends on you whether you want to use M3.0 or memory byte 3 or memory word 3 or memory double word.
Okay.
So the moment I put it here, automatically this one will use 4 bytes. So the next number I need to see which number is available. It's not like MD0 is already there. No, you only have the bytes only. If the byte 0 is occupied already, next byte is available 1. But what I want to do, I want to use MW or MD.
Okay.
Something like that. Okay.
Little bit confused.
Little bit confused which one?
Like for example, the memory word 0, right?
Yes.
Then the next one won't be memory word 1, right?
Of
now we talk about it.
course, I say.
Yeah.
You listen.
Yeah.
Of course. Why? Because I already used MW0. Okay? I already
correct.
used.
Yes, correct. You already used MW0.
So
but
the next number is
it will be MW1.
no.
But yeah, that's what I'm thinking.
No.
But it doesn't exist because it starts from 2,
No, it's not like doesn't exist.
Yeah.
No. Because if I'm using MW0, this guy will use 16-bit.
Okay.
This guy already used memory byte 0 and memory byte 1.
Yes.
So the next number I want to use, I cannot use 1. I must, okay, let's say there is a 16 members. Okay, 16 members. So you already used the 16 members.
Okay.
Let's say there are 32 people here.
Yeah.
I'm forming one group.
Okay.
Okay, this example will be very easy. I want to form a one group. I already used 16 people.
Okay.
So you want to form one group. You only available to take the balance 16.
Okay.
The balance 16 starting with number 2. So that's why your group name is 2.
Okay.
Okay. Let's say I got 32 people. I want to form 8 per group.
Okay.
Okay. So I already take the group. I form them as a 0. Now you want to take the balance another 8 people. You can form as a 1.
Yeah.
You got it?
Yeah.
Okay. Now, I want to make a group. But I only want 3 people only. So I already use 1, 2, 3.
Yeah.
Okay. So I name it that 0.0, 0.1. So I means I take a group. Means I take this MB0. I take one group. But I only use the 3 people only.
Okay.
Okay. Now you want to form 32 people.
32 people. Okay.
But you cannot take my group already.
Correct.
So you must take from the group number 1.
Okay.
So your group title name will be 1.
Okay.
That's why I put it here 1.
Okay.
You got it or not?
Yes.
So it depends on usage. It's not like they fixed. It depends on your usage.
No, I understand that.
Yes.
But the MD1.
Means because this one I already used.
Yeah.
So I cannot take the 0 already. Now I must take from the 1. The one you got it about.
Oh, okay. Ah. Yeah, okay. I got it already.
Yeah.
That's why you explained the MB1 plus MB2, that one, huh?
Yeah.
Yeah. Okay.
So if I already, so means the 0.0 already used. Next available number is 1. But I want to form a 32-bit group.
I mean, if I'm happy, I can also start at MB2 lah.
Of course.
Yeah.
Any number you can start.
But then the 2 will consist of 2, 3,
4,
and
5.
Yeah.
Yes, that is correct. That is what I want to do now.
Okay.
But this one you understand right now, huh?
Yeah.
Okay. So inside here got 1, 2, 3, 4. So here will be the next number is will be because here also must be MD lah, right?
Okay.
Because of course this is the double integer means this is also double integer lah.
Actually, ET is what?
ET is the elapsed time. The timer running,
okay,
right?
okay,
The
yeah.
So this one will be MD 5. Correct? Okay. But we don't use odd numbers.
Oh,
Because difficult. Because you know 1, then 5, the next number is what?
let me see.
Difficult, right?
Yeah.
If I start with 2,
Okay.
2, 6, next number is what?
2, 6 will be 10.
10,
Yeah.
14, 18, will be
Yeah.
easier.
Yeah.
So, I make it 2. So, even though this number is available, I don't use because it's hard for me to do the numbers. Even the software itself, because like you said just now, you can put a name and you can define.
Yeah.
It will automatically give you number 2. It won't give you odd numbers, it will give you even numbers.
Okay.
But an odd number can do, but I never seen in my program.
Okay.
Okay?
Yeah.
Good. So this is how the this one become okay, this one I tell you take picture. So 2 means inside here got 2,
2, 3,
3,
4, 5.
4, 5.
Yeah.
Yes. But this one is very interesting. And will be confusing also.
Yeah.
Okay, good.
Okay.
Okay, you off the MD0. Sorry, 0.1 is you off.
This one, right?
Yeah.
Okay.
No, click properly. No, choose the name now. Okay. Now you put the MD. No, you don't put MD2. You go and key in here. Okay, one more thing I want to show you before you minimize this. Okay, you right click the PLC. Can you see assignment list?
Yes.
Okay, click that. Assignment list means it will show you which memory is already used.
Okay. Oh, wow.
So you already use MB0 and you already use the bit 0, 1 and 2.
Okay.
The next number is available but logically 1, right?
Yeah.
Okay. Go back to your program. Okay, you put a name here. HMI timer in.
Timer A.
Timer in.
Oh, okay.
Right click, define tag. Okay, choose global memory. Can you see by default give you MD2. But just now in the assign even number, right?
Yeah.
So this one is it. Okay, define. Then this one you will define. Also can manually key also can. HMI timer display.
HMI timer display. 76. Okay.
76. When you use data block, DB, you won't have this issue.
Okay.
You know why? Because DB, you won't be manually keying in the address. You will give the name. The address will be automatic.
Later we see.
And then of course, the one
Okay.
is
Yeah.
okay. Now you download this and test. But more on this one, right? Memory word, double. We will learn also. Okay, we will learn maybe the next class when we use max function. Or maybe after this we do the max function.
Okay.
Maybe the HMI, maybe the next class we learn.
Yeah.
Because you know how to use the HMI, right?
I only know how to plug in the variables into
Yeah.
there lah. Then after that they can control already.
Yeah.
Very basic stuff.
Then I think maybe the next class we do the HMI. Then later we go and see the data types. It's very important. You see, already put some value. How? Any idea?
The value is the MD21 or motor one. MD21.
MD2.
Oh yeah, because okay.
What some value? 7 days something, right? You rightly change to decimal.
Oh, that's what it means. 7 days, 14 hours.
Yeah.
Okay.
Rightly.
Okay.
Display format. Tag. Decimal. You see the number is very big. 6553600. Why? We didn't key in any number into MD2, right?
MD2 times this. Yeah, it's so far away.
Okay, you know why?
You can use it.
Okay. You see, just now in the watch table, you key MD0, you key 10,000.
Yeah.
The 10,000 go and occupy these 2 bytes.
Yeah.
And now you are using MD2. Correct. Now inside MD2, here got some value, here got some value.
Oh yeah, it's under 2 right?
It's still right.
Yeah.
So now the 4 and 5, because the arrangement will be 2, 3, 4, 5.
Yeah.
Correct. So now the 4 and 5 is empty, all 0. So 2 and 3 got some value. So that's why that is the value. Okay? Because just now we key in the value inside the empty 0. That is the value. Okay, we change it. You change to 10 seconds. Just put
value 10s.
10s. Okay. Now 10,000. You change back to time. No, right click the name. Yeah. Display format. Tag. Automatically. Okay. So now you press that. So you can run for 10 seconds. And you can cut off.
Yep.
Okay, good.
Okay.
Alright. And
All this memory is not in the database, right? So it basically will reset once we stop it.
yes. Once you off and you stop and run, you try and see.
So this one becomes 0.
Yep.
So I have to redefine that again.
Re-key again, key in again.
So that's why I need a database.
That's why you need a DB.
Yeah.
It's not a database, it's a data block.
Data block. Okay.
Yes.
Yeah, okay, I understand.
Okay, good.
Yeah.
Okay. We take a break. Then after the break, I think we do the max function. So we can learn on the memories, some memories, how to use the memory.
Okay, sounds good.
Yeah. Because data type is very important.
But the software will catch this kind of mistake for you.
No.
The time when I was like studying all this on my own, I did see a lot of examples, but I didn't really catch what they're saying. So now I roughly get it.
Yeah.
They found the mistake by just now the watch table thing. No,
Yeah.
not watch table.
Assignment list.
Yeah, assignment list.
Yes.
Yeah, they caught the mistake there. But I didn't really catch what they're saying until now.
So it won't show error in your program.
Yeah.
Because it can use, because sometimes you will be using like that. Sometimes not in this, for example, I just give you, okay, sometimes like this, then suddenly you will use the MW2 and MW0 suddenly, because maybe two people, 2 MW combined become 1 MD. That will also sometimes
Overlap lah, okay.
so you can use also. So that's why in your program, if you put MD, you already use 0, right?
Yeah.
If you put MD 0, it won't give you error. It won't give you warning, it won't give you error, nothing.
But you give you just now that kind of very strange number lah.
No?
No.
Yeah. Of course, that the value.
That one.
Yes, the value of course
Yeah.
will give you a strange value, but it won't give you error or warning.
Yeah.
Only thing where you can search is you can do search in S7. Same thing. Just now I showed you the project I do, right?
Yeah.
Same. I was doing. Normally I don't like to use put the name and automatic assign, because normally what I do for this memo I will assign myself. You know how you know?
Yeah.
From byte 0 until byte 9, I will use like this as a boolean. Starting from 10, I will use as a word.
No wonder, because I was looking at how those users segregate. Like I didn't understand it's for this. Yeah. They specifically assign, right?
Yeah.
0 point something or 110 something like
Yeah.
this for a specific data set.
Yes. So they
Yeah.
will. So for me, it's so same.
Yeah.
I was doing, then I by mistake as I overlap something. I didn't realize.
Yeah.
What happened is testing. Cannot go. And I go to the assignment list and see. Then I see there's one place I use as a boolean and I use as a value also. So what happened? It's supposed to on this, but since I'm always forcing here, I forcing the value 0, always go forcing 0 here. This one cannot turn on. When this one cannot turn on, it cannot turn off the motor. Something like that.
Yeah.
Happens because it didn't give me warning in the program. No, program not working. I see the program, for me it look like all okay, all perfect, everything good, but cannot run. Then I go and test. Then what I do? Then only I start to use the rest of the project lah. I think after done, the balance like 20% of the project, I use the name. I put the name, giving automatic define. I don't like automatic define. You know why? Sometimes, let's say I already use 0.0, 0.1, okay, and I use 2 already, right? Let's say that I already use all the 16 bit.
Okay.
The next one automatic assign will become 10.0. Because 6 already used. 6, 7, 8, 9. Next number is 10. So suddenly become 10.0.
Okay.
So here in your program it becomes 0.0 until 1.7. Suddenly become 10.0. So it's not look nice, you know. So that's the problem I have. So that's why always I will allocate. Okay, this one is for boolean. From this to this is boolean. From this to this is a word. Better.
Yeah. I thought you were just separating it for the sake of separating it, but actually there's a real reason behind it.
Real reason, yes.
Yeah. Pretty good, learn so much today.
Yes.
Oh, and just now the main, that flow one, still have to digest.
Which one?
Because we are following the very simple flow, then after that we do the testing, then after that we have to redo the, that was really like what you say logic I think still have to go and slowly go and learn.
Yeah, of course. The one need to practice, need to do projects, a lot of projects. Yeah, of course.
Like just now that flow actually quite simple, actually quite simple.
Very simple.
Yeah, then like, wow, just spiral into.
Okay, now what we do? So we want to do the next function, right? Go offline, you add new block. You add another FC, you name it as the max. Because here we're going to learn a lot of data types. Okay, then go to main OB1, you drag and drop the max block. Can at the side also can, go to level 2 also can, not the issue.
Yeah.
Okay, go back to the max. Okay, go to the max function here.
Right.
You take the addition. Put it here. Okay. Inside here, you click here. You can choose what data type you want it. Integer, double integer, real, or long real, unsigned short integer, unsigned integer, short integer, unsigned double integer. So depend on signed or unsigned and real. Okay? Okay. Let's say we choose integer first. Integer means it's a 16-bit. So just now you go to program info. We already used until 9, right?
Yep.
Because we use number 2 until 5 as a double word.
Oh yeah.
6 until 9 as a double word also. Okay, so next available number is 10. Okay, click here. So n is an integer, so you must use MW10. The next one will be MW.
Then 10, so 15.
No.
No. 10, 11, 12, 13, 14.
No.
No.
Because 10 word we
Oh.
got 2 only.
Okay.
10 in 11.
So 10 is. 10
Next number is 12.
10 is 10 and 11.
Yes.
So
Next available number is
12.
12. Okay, next one is MW
14.
14 please. Oh. Yes. So addition is very simple lah. Whatever value you give here, we plus with this value, the result will be here. Okay, good. Okay. Save, download and test.
Oh.
But when you see here, you open here.
Sorry.
Yeah. You see, there's no word or double word.
Oh yeah, how come?
Right? Because, like I said, word and double word is in hexadecimals. Because addition only can use for decimal and floating number, floating points only can. Okay. Download and test.
Watch table.
Okay, here itself can be monitor.
Okay.
Monitor, you can double click here also. Okay, double click on the value, you just key in some values. Okay, what do you get?
So 3000.
1000 lah. Okay. Put some bigger value. Put like 20,000 plus 20,000.
Oh, so there's a mistake of 25536 today.
Okay, why?
Definitely because the exit next up already.
Okay. Because integer, right? You go here, go to the side, go down, there's a table for the values. Okay. So integer means it's a sign lah. Okay. INT means it's a signed integer lah. UINT means it's an unsigned.
Yeah.
Sign is negative 32,000 to positive 32,000. So your result is already above this number already.
Oh, so actually if we use unsigned integer, it will still produce the correct
Yes, you will
information.
get the 40,000.
Okay.
But why that number? There's some number, right? Can I erase this?
Let me check if I check this.
Yeah.
Just add one more.
Yeah.
Alright.
So the value is go to negative, right?
Yes.
But actually there's a reason why negative, okay? Because one is okay lah, overshoot lah. But the value also is actually correct. The overshoot value because the idea is how it goes on is like this. It's a negative 32 768 to positive 32 767. Okay? That's not the total value is 40,000, right?
Alright, yes.
So I from 0, this is 0, from 0 I go to here. Then the balance will be how much? 7 something. 7,000 something, right? The balance. Okay. So the balance actually will start from here and go towards 0.
Oh,
So the balance will be added here.
wow, okay.
So of course lah, negative 32,000.
Oh, no, it was minus just now. Okay.
Okay.
Yeah, it's minus 2 something. Yeah, okay.
So this value is the 7,000 and this position is 25536. The bigger the number, the it goes towards the 0.
Yeah.
Okay, good. Okay, that's how it works. Now, so in this case, what I do? Let's say
Oh,
lah,
change the on top here.
don't change, do another one.
Oh, okay.
Okay. So in this case, of course I need to change lah, but I want you to do another one. You can put beside also. Yes.
Alright.
So you choose double integer. Want to use unsigned also can, double integer also can. So if double integer, must use M.
It won't have this problem, but the next one will be so 16 can.
16 can, yes,
Yeah.
correct. But M what? MD or MW?
Integer is until what?
MW.
Wait, because integer is in decimal, so double integer. Should it be double?
Yes. No, my question is very simple.
Yeah.
You are using double integer, right?
Yep.
So do you want to use MW16 or MD16?
I'm not sure.
Very simple. MD. Because it's a 32-bit word. Double integer.
Let me have a look at the slide again.
Yeah. Double integer, 32-bit.
Is two words lah.
Yeah, 2 words.
Okay.
Ah,
So it's MD lah.
yes. MD 16.
MD 16 correct.
Okay, why 16? Because the previous number is
These are the
MW
two,
14.
Yeah.
Yes. This is where always they do mistakes. Next one will be MD.
MD to MD.
Yes, correct.
Oh yeah. So it's
Now you try this number.
okay.
Now can get ready.
Yeah.
Right? So WJ can go up to 2.1 billion.
Yeah. 1 million.
Yeah. Okay, good.
Yeah.
Now what I want you to do, I want you to try some other math functions like multiply, divide, subtract, some others, and I want you to try some others like real, integer, short integer, all that.
Yeah.
Okay?
Okay.
You try it. You try first, then you see any issue. You face any issue.
Just change this.
Okay, if you change what happened? You change?
Oh, then after I have to do this.
Yes.
Yeah. But this one, if I change it to a signed integer.
No, signed integer don't have. Unsigned integer only have.
Oh, sorry. Makes sense. Okay. Unsigned.
UINT.
Yeah. So that short integer is
SINT
yeah.
is
Okay.
short integer. So you put UINT. But
this.
wait. But can you see the small box here?
Yes.
Okay, you know why? Because earlier you choose integer, right? And you put MW.
Yeah.
You right click the MW, rewire. Make it bigger. You see, okay, never mind. It's 3 lah. Okay, you see, make it this one address bigger. Okay. Because earlier when you keep keying integer here, then you key MW. This MW will follow this. It become an integer, right?
Yeah.
All these become integer. So the moment you change here, it defects this. So it will show that you might get some error. Even though it's supposed to give you 40,000, in MW14 it will still give you the negative value.
So that means I have to rewire lah.
Rewire.
So that's what the box means.
Yes.
Okay.
The box means cancel. Bring the mouse to the box. Wait, you see, implicit conversion from integer to unsigned integer.
Okay.
Runtime error are possible. Okay, why? If the value within the range is okay. If over the range means what? Very simple lah. Your calculation is it can calculate up to only positive values, correct? Unsigned integer. But your here the limit is this is the limit.
Yeah.
So sometimes you won't get the proper values.
So basically this one is
This is data types. Very important.
That means every time I change this one,
You
then
change.
I must remember to just rewire.
Yes, rewire.
Yeah.
So that's why I don't change normally. I do another one. But if I do by mistake, then I change. So for me, I don't want you to change. Why? You change back to integer, then create here. Then in the comment, right? What you can do, you put it here. Just put INT. Integer can use MW. integer equal to -32768 to 32767. Enter. So for double integer, same. You put double integer, can use MD. Then double integer equal to, you copy from the slide number. Yes. You know why? Later, if you want to refer to this file, when you open, so you know. But there's one problem. You know what is the problem? Because we are using version 18.
Yeah.
Your laptop is version 16.
Oh, yeah, we're gonna upgrade it, right?
Then we upgrade to version 18.
Yeah.
Because whatever you do right, later you cannot open.
Yeah. Yeah.
So what you do, you see this week, the whole week, you see if you want to uninstall, then you can uninstall that, or you just bring it, I can uninstall for you. Or you just give me around like 20 GB space. I install the version 18 also. So in your laptop 16 and 18 also.
Okay.
You in the second network you try to use some other functions.
Okay.
Then I want you to try to use the real multiply, divide, all that.
Okay, so I'm at the, after subtract, after multiply, I'm at the NEG and the modulo. So NEG,
Negate.
yeah, it's supposed to convert a negative value into a positive value. Isn't it? What is negate?
Yeah, supposed to do that.
The subtract multiply no problem.
Modulo is the, you know what is modulo?
I read the help lah.
It's a remainder.
Yeah.
You divide, right? The
Yeah.
remainder.
But I got a problem.
Well,
Hold on.
because you haven't downloaded, you need to download. There's a changes.
Right. So this memory word 50. How come it's already
In Excel,
yeah?
because it's in Word.
Okay.
The MW50,
Yeah.
the data type is in Word. It's not a integer. You right click and try to rewire. Keep the name, always name. Yeah. Rewire is in Word, not integer. You know why? Because you see, when you choose this, then you key in MW50, yeah?
Yeah.
It will follow this. Before you choose this, and you key in something here, it will always go to Word because you put MW. MW is considered Word.
Okay. Because just now it's under automatic.
Yes.
Yeah.
Okay. And these two Y got the same thing here. You see what you check and see? Why? It's an unsigned integer. So this also change. Change to integer.
So whatever that just changed, I have to download again.
Yeah.
Okay. Let's just use this. So modulo, right? Let's say it's 10 or something small, okay?
10 divided 3, balance is 1.
How long?
10 divided 3
Yeah.
is what? 3, right?
Yeah.
The balance is what?
Oh,
1. There's a remainder.
so if it's 2, 0.
Yeah.
But what's the point of this?
Because you see, you do the multiply.
Multiply
10 divided 3.
10 multiply by 3.
No, you don't have a divide, is it?
Divide, no.
Okay, you add one divide.
I just add the back here.
Okay, anywhere. Beside the modulo also can. You put the same MW50 and 52. The result you put a different one.
Okay. Wait.
Okay, wait. Now you can key without this integer. You know why? Because you already put MW50 here, right?
Yes.
When you put 50 here also, it will follow the same data type.
Okay.
But now I choose. Practice choose.
one will be NW56.
Yeah. Okay. One give you the result, one give you the balance lah, the remainder.
In what application will I use this?
Good. I use the same. Now I'm producing bottles. Okay. Then I go and pack up in a 24 one alternate. Okay. Now I want to calculate how many cartons I've already produced. Okay. So let's say the MW52 is a 24. Put 24. Okay. Then let's say I put 78 bottles total. Example lah. Now here 3 is the number of carton I've already done.
Oh, 4 is okay, yeah.
3 lah, right?
Yeah.
6 is the balance 6 bottles. I have.
Oh, maths. Haha. Okay. 78, is it?
Okay. Or you put 50 lah, let's put 51 example. Yeah. So 51 means 2 box is already ready.
Yep.
There's a 3 more bottles is there. 2 carton.
Oh, interesting.
You want to calculate this way.
Oh, interesting. So actually this one saves you a lot of time. I mean, you can do it the maths way as well.
Yeah, of course, there's a max actually.
Yeah, you can do it the long way, but this saves you time.
Yeah.
Then
Negate. Why the negate just now you said what is the problem?
so this one, no, I said I want to ask what's the purpose of
It will negative become positive, positive become negative. I think so.
But right now I cannot because it's not unsigned.
No, integer is a sign and sign one. Positive, negative.
So unsigned is the one that
Positive value only.
Oh, okay. So let's see.
You put 25.
25.
So it become negative 25. Okay. You put negative 25.
Oh, let's see.
Okay. You take another divide because I want decimal point number. How?
Change the integers into a live
Real.
real.
Yes. You take another divide. You don't disturb the divide. Okay. Yes. Choose real.
We use like
Real means M.
real is I think it's also a double word, right?
Yes.
Yeah.
MD. MD what number you can use?
The last one is 56,
Yeah.
57, so 58 lah.
Yes.
one
Real.
yeah.
Change, right?
No, but it's because the display, you need display in
Automatic.
real.
Yeah, automatic. Must be automatic.
Okay.
So why is in EXA? So I think it's in double word.
Yeah.
Change to real.
Under here, right?
Yeah, rewire.
Okay. It's under real.
Oh, real. Okay.
Yeah.
Or maybe no value because of that lah.
Okay.
Okay, put some value first.
So this one we change. This one is on D5, okay?
Yeah.
So 10. Okay. Yeah. increment block, the output how come don't have
keep on increase.
Oh, so here need to something trigger.
Yes. Need to trigger that will increase.
But where will the data be stored?
Yeah. So every time you enable, you count 1, 2, 3.
Oh, okay.
Same like a counter, only different is counter will have an output.
Yeah.
Once you reach a set point, we have an output. Increment is just keep on increasing.
Yeah.
Increment is keep on increasing.
Counter operation. Okay. Oh, we haven't got to this. Count up.
Okay.
For this absolute value, right? How come it doesn't change it to a 3?
No, absolute value is remove your negative positive. That is absolute value.
Oh.
Like negate is convert right negative to positive.
Yeah, whatever, then you just flip it around.
Yes, this one just remove. If positive means positive, negative means you only take the value, not the sign. You see this one keep on increasing.
Yeah, how come?
Because every time I scan, I update.
Oh.
Because no input in front.
Oh, okay.
Because it's 16 is in word, right?
Yes.
So what happened is it will be like go up to 65,000, go back to 0. Go up to 65,000, go back to 0. That one is different lah. We go maximum values and everything.
Wow, there's still so many.
Yeah, boss. You see, got exponent, sine, cos, all that you have lah. The one is when you do calculation, when you can use lah. Minimum, maximum is you will take the minimum value you get.
It means what?
You take a good time.
Maybe I get rid of this.
Yeah.
Okay. Using 70.
Okay. You put minimum. Okay. Say.
Let's go for
Teacher. Okay. Then you put the MW 70, right?
this one is how much? 36.
Why 66? What's it?
Oh, because that's how I thought they transfer from 3.333 into 3 ma. Yeah, but that's not the case lah.
No,
Yeah.
that one is different.
So 66 minus 70.
70 and 72. Okay, now like this.
But just now I used a memory double word at MW70. But it's not
already
used
removed.
anymore.
It's already removed, right?
Yeah.
That is okay.
How come there's a 2235 something?
I don't know.
Oh, maybe
Oh,
it's
maybe
just
from
now.
the previous one.
Yeah, maybe from just now.
Yeah. Just put
Oh yeah, because it was counting up, right? Okay, so
put some value.
2000. Alright.
Okay, what do you see?
1000.
Why?
This one is minimum, is it?
Yes. So you only take the minimum value.
So maybe this one for data logging too, lah.
Yeah. Because the star here means I can add multiple inputs. I can add the star again many inputs.
So how do I add the third input, for example?
Just the star. Click the star. Yes.
Oh wow. Okay. what's the use case for your limit block?
Limit.
Yeah.
Limit your value.
Yeah. Like 1,000 and my maximum is 5,000. Then output of course is 1,000.
Okay, you put 3,000.
Where?
The input.
Yeah.
So means it will the whatever the input value, if it is within the limit, okay, I will transfer the input value to the output lah. If below the limit, I will use the minimum value here. If above the limit, I will here.
This one is for like motor control.
Motor control, many things like analog readings, analog settings, all that. So let's say analog reading,
Yeah.
you want the temperature to be shown in the HMI. For example, in the HMI it just show 0 to 100 only. But some sensors can read from negative 50 to 1000 plus. So here you want to limit. So if below the 0 value, let's say go to negative 2 temperature, but in the HMI it shows 0.
Okay.
For example, like that.
Yeah.
So I want to limit the values you can use. Normally for analog sensors lah, I use the limit. Okay, good.
Good.
So this match function, I just show you because we want to learn two things. One is the addressing, okay, when to use MW, when to use MD, when to use real, when to use double integer, when to use integer, right? So because in PLC these are the most important thing, data type and addressing. Because you say you want to take the data from your load cell using the Modbus, everything, right?
Yeah.
All that involves two things only. Okay, what data you want to take? For example, you want to take the current rate. Two things important. One is what is the data type? You are taking the data, right? What is the data type? Is it a word? Is it an integer? Is it a double integer? Then, if word integer, what memo M or DB you want to use? Whether you want to use an integer or word. So these two. The rest of the functions is all around this only, using the data type only.
Yeah. Okay, save.
Yeah, you can see.
Yeah.
Okay, good. So then I write it down. First next week, continue, right?
Yeah.
Okay, that's nice. This once we already covered this one, then next week we can straight away go to the counter with, yes, I'll show you lah how the counter works. Then we go to the compare FB, FC, DB, and Modbus. First, next week we cover that one. On the last day, then only we cover the drive.
How about the what?
The drive, Siemens drive.
Okay.
We do the Modbus first, because you see you want to learn the Modbus first, right?
Let me see if I can bring down that.
Your device.
Yeah.
Yeah.
That's the most. I'll get the most out of this lesson.
Yeah.
Yeah.
If you can bring them, it's okay. It will be advantage for you. You can learn from your device.
Oh, it's beautiful. I don't know how I got it to. I don't know how I got it to.
When you follow the
Let me think. How do you get it to work? Oh, I use the external software. I didn't use the portal. So you know that they can send the to address you need. So set what variable. So I just send the instructions. They say if this is at this state to this address, it will turn on.
Okay.
Then speed is controlled by this variable in this address. I just send inside there. Then I think rest turn on.
Okay.
But that one is all manual control. Yeah. So from there, like, oh, okay, so this is how it works. Yeah. But actually, it sounds simple lah. Maybe I go and rewrite the graph set first. Yeah. It sounds simple lah. But you know, I just found that one.
Yeah, okay, because now it's second day. But I mean, if you later when you go back and if you have the picture of the what's it? Your range scale, right?
Yeah.
The picture of part number, I just send you my channel.
I have the handbook for that with actually it's just one table, 2 pages only.
Okay.
Yeah, the table spill over in the second page. That's it. Yeah.
But there's for the Modbus table lah.
It's for okay. So basically what eventually I want to do lah. Okay. So one device will control these 3 microcontrollers. So this controller, right, actually is one controller to one vibrating dispenser. Okay. Vibrating dispenser go inside a basket. The basket has a gate connected to a load cell. So once let's say 1 kg come down, okay, enough. Vibrating thing, stop. Door open. But you wait for my panel foot switch to say open. Yeah, it's just like that. Then the thing will just loop. Yeah. So right now, that is what's available in the market. What I want is vibrate 5 kg down. Every 200 or 300 gram, there is an output to a pneumatic device. Because I need to put additives inside. Yeah. It's just like that.
Okay.
Yeah, that's it. Then of course these 3 will run independently. Yeah.
So now you want to control using?
These 3 basically can operate on their own.
Okay.
Like there is a panel to press.
Oh, press.
Yeah.
Okay.
So I can just press start or stop. Then I just connect a foot pedal, then it will also run. It's just that I need to read the internal memory of what is the current weight right now. So let's say it reaches 1 kg, right? Okay, drop 200 gram. Drop activate something lah. It will just drop into the basket. Yeah, it won't interfere with the ordinary disk loop lah.
Okay.
Yeah.
So the thing is, there's a microcontroller who control the things lah.
Yeah.
What you want to do is, you want to take data, what is the current weight from the microcontroller.
Yep.
Is it?
Yeah.
From microcontroller to your PLC.
To my PLC, so that the PLC will know right now is what weight.
Okay. Then after you know what is the weight, what you want to do?
I want a variable where I can set. Okay, every let's say reach this stage 1 kg, activate pneumatic piston 1. Reach 2 kg, activate pneumatic piston 1. Yeah, there's only 1 piston. Yeah.
Okay. So the piston will control by PLC,
PLC.
not by the microcontroller.
No, there's no more outputs really. This is specifically built to control only the hopper, the load cell, and the gate.
Okay.
Yeah, this was ready on the market lah.
Okay.
Yeah.
Should be okay lah.
Yeah, it's kind of like a workaround lah. I work with what we have on the market right now. So PLC obviously can read what is the current weight. It doesn't have to write it there, it just has to read. So once it reaches whatever that I want, so I wouldn't know how to configure it right now. Like do I want to have 5 different stages? So I need to have a variable where I can control how many stages are there. I wouldn't know. Should it be at 1 kg or is it 500 grams? So every time I'll dispense at 5 kg.
Okay.
So how many steps does it take? I wouldn't know right now.
That one is okay. That one.
Yeah. So there's a variable to control how many steps. Then 1 or 2 piston moves. You know. it. This part is something like that. Yeah.
Then why didn't you use Arduino for that?
Arduino. I couldn't get it to work. Because originally, right, these three, I haven't found this guy yet. So this guy is the first guy who built the Modbus into this controller.
Okay.
He's the godfather of this thing.
Okay.
So he added this Modbus. The other original hardware that we had, right, don't have Modbus on. Yeah, so back then when I was messing around with this, Arduino, I can only take so one machine can have 3 or 5 or how many of this microcontroller. Max is 6. Yeah, so all of them will plug into another sideboard. So this sideboard has the chip where they have a real counter inside. So they will keep track of which one is finished first. Yeah, you know the chip, right?
Yeah.
Those 8-link one. So you will keep track of which one finished first. Then whenever you step, right, they want to go down. Then the counter will change. Then you step. Then the next one will go down. Then it will start to refill. So this will be tied to this one. Then this one will go to the foot switch. Yeah, it's quite rudimentary one. It's all hardware. It's all analog. Yeah. Then this guy came out with it. Then by the time I tried to take the signal from the counter, but it was I don't know what is the nature of this signal, but I do know that it will have a high voltage. I think it's about 3.8 volts. Yeah. Every time it's ready, it will have a positive output of 3.6 or something but it wasn't stable. I don't know why. Yeah. Yeah, I also don't know why.
I need to know what is the controller that may get an idea.
Yeah, so from there, I wanted to take a signal. That's the most straightforward way because you know that I tried to have a workaround. Instead of weighing the entire 5 kg, I just weigh it in 1 kg, for example. Then I can activate the pneumatic. So I just repeat as many times as I need in the microcontroller. Yeah. But the signal, the positive voltage was not stable. Because Arduino need about 5 volts is the on. 0 is anything below 2.4 or something, I can't remember already. Anything below that is considered 0. Anything above that is considered 1. Stable. Yeah. So 3 point something, okay, I can make it work. Yeah. But the stable fluctuates, the signal fluctuates, it's not stable. I don't know what's the nature of the signal. So back then it failed. Because once it fluctuates below that point, right?
Yeah, you won't get it.
It will become like, 1 already.
1 already, yes.
Yeah, so then I was very fed up. Couldn't get it to work. So we just went with the half automatic way. Yeah, so we just pre-mix everything first. Then just dispense as per normal. So you just skip the pneumatic part. Yeah. And it still works. I mean, it will be better if you can do it that way. If not, then just continue that way.
Yeah.
Yeah. So if I can learn that Modbus part to fix this, fantastic.
Okay, good. So whatever we have to say, we close, then we can continue to next.
Yeah. Saturday same time.
Yes. So you going back to Singapore? You staying here or going back to Singapore?
Oh, later I'm going back already.
Oh.
Yeah, I have a yakitori nearby first.
Okay, but Monday to Friday?
Monday to Friday working
Where?
Singapore.
Singapore lah.
Yeah, but if when I'm needed here, I'll come in
Then only you come here lah.
Right now is right now we have people coming next week so maybe I can yeah, but I'll be busy there lah.
No, okay, no, just asking only because you say the company is here, maybe you might want to stay here.
No, if I stay here, I probably stay at the factory. It's pretty sweet yeah. Not good. Because you know that the developers, right, they actually very smart. I don't know whether they planned it in advance or not. So all this palm plantation, right? Once the trees are mature, no longer producing the palm as much, it's useless to them. Right?
Yeah.
You reach a point where it's not worthy anymore. Because it's too high already, the harvesting becomes a problem. Yeah, so they chop everything down. The ground already very stable already.
Yeah.
Redevelop into whatever factory, residential. Yeah. So in front of the factory right now is all the old palm plantations. Yeah. So it's a undisturbed land. They are not doing anything there. There's nobody working. It's like, yeah, the climate there is pretty good. Yeah. But I think there are some illegal people staying there. Yeah. That time during the Hari Raya, went inside here to shoot all the fireworks. Then I think too noisy already, because after midnight already, then they started to throw like branches at us. But we couldn't see them, it's totally dark. Yeah. So we just better stop the rest. Much things involved.
Hey, when you go day by day, there's so much things we need to do. After this, no more like logic, okay, where this one on. After this, more on data types.
Data types.
Yes.
Alright.
Integer, double integer, because all these are. So, later, after that, we learn counter. Okay, counter is a logic lah. I count, I give output. Similar like a timer. Then compare, okay, logic. Then after that, FB, FC, all we don't see logic, because you want to know how to use those blocks, right? So we'll be using a simple logic only. Then when we come to data block, it's more on data types, integer, double integer, all that. Okay. Then move data type, scaling data type, Modbus data type, VFD drive data type. Data type, value.
The VFD basically is the mobile communication, right?
No, VFD is a drive.
Yeah.
The Siemens drive.
Yeah. That one is communicated by the Modbus.
No, if Siemens drive, I can communicate using Profinet. If other drive, I can use Modbus.
Yeah.
If other drive, the other drive cannot support Siemens communication, then I use Modbus.
Okay. Sounds good.
This one I need to do. I need to do both. Then only you can understand the differences. Okay. Why?
VFD is a drive. FBD?
It's a function block diagram.
Function block diagram. Okay. Yeah. I'll try to bring the stuff next week.
Yeah, you see. If you're able to bring, then we can just explore that.
Yeah. Sweet.
One turn on.
No, it's still there.
Oh, oh, oh.